session. Reason for that is that we want you to be able to go back and view the recording if you wanted to check something at any point. Also, if you missed a session or part of a session, you could catch up on the recording. I do put a little content warning out there in terms of the fact that we do show some road crash scenes and crashes, and we're using those to try to work out how to stop them in the future and the like. But if that's something that could disturb you, I just be aware that that there are something, nothing overly graphic, but just be aware of that. So I'm going to be your program moderator. I'll present a couple of short sessions, but Jamie and Evan will be doing the bulk of the technical content. But I'll be behind the scenes the whole time, monitoring the chat function. And that's the way we want you to put in your questions, your comments. So as we're going along, just type things in. If they get covered in the content before I get to feed them through to the presenter, then I just won't ask them, or I'll be behind the scenes, maybe answering a few immediate questions. So use that chat function as much as you want. And as was said earlier there, you can either, with the little drop-down arrow, you can make it just to myself and Jamie, or you can do the drop-down to everybody. And it's nice to have a little bit of banter going on there, a little bit of chat about different bits with the everybody. So encourage that as a way to get a bit of discussion going. If for some reason the chat's not working, then use the Q&A function. Occasionally a firewall decides to cut out the chat. Now, we do have the ability to unmute you. It's not really our preference because of the challenges with all the audio and dogs barking and things not working, and it just runs us often into trouble. But we do have that that option. And so if there's something that you'd like to specifically talk about, you can raise your hand, and then I'll find you and give you the ability to unmute yourself. There is no ability in this forum for your camera to go on. So you can happily do this course in your pajamas and nobody will ever be the wiser. You should have received a link, an email from Safe System Solutions giving you a link to Moodle. Moodle is our learning management system, and it's where we house all the resources. We house the assignment that you're going to have to do, the test questions or quiz questions, which have to be done at the end of each module. So you're going to have access to this. So hopefully a lot of you already do. If you don't, you need to make sure you get that. So maybe send an email through to either myself or whoever sent you the email link to log into this. So you've done that because we need you to have access to that. Ideally, you have access to that by about 10:30 because we're going to get you to do a quiz in between two sessions while you have a bit of a break. And the quiz is housed in Moodle. So hopefully you've got in there. I will show you through that when at the end of this session to get you going for the quiz. Another little character that appears throughout the course is Wally the Wombat. Some of you know Wally already from Road Safety Audit course or our Safe System Assessment course or the like. But Wally the Wombat warning sign, there's one there, appears just a number of times in each session. And you've got to keep an eye out for Wally. And one of those quiz questions at the end is how many times did Wally appear in the session? And so you want to keep a little track of Wallies. This is not one of your Wallies, so your Wally count is 0. But just keep an eye out for Wally on my slides coming up and Jamie's slides. Keep a track, and then when you do that quiz at the break, see if you can get that Wally count right. So we have some competency requirements as part of this course. So have to prove to us before we give you your certificate that you have met a certain set of competencies, and some entry level stuff is just turning up. 3 of the 4 webinars. We've got 2 this morning, 2 on Friday morning, and you have to attend 3 of the 4. Ideally 4 of the 4, but if you absolutely had to duck out for something, you can catch up on that. You've got to successfully complete the task, so you've got to do all the quizzes and assignments, and you need to get an 80% pass mark on all of them. So those that are marked, actually they're all marked, so you need to get 80%. Now don't get too stressed out about this, because you get 3 attempts at every one of them. And if you don't do so well in the first one, you can just get some one-on-one coaching with myself or Jamie, and we will go through and we'll work on areas that you don't quite understand, and we'll really hone that in and make sure you get that 80% pass mark, because we fail if you don't pass as well. So we fail if you fail. So we're not going to let that happen. And the way we're not going to let that happen is to build your capability within road safety barriers at that fundamentals level. I'll introduce our presenters in a second, but I will say that there's another little thing that we like to do in these online trainings. So lots of little tricks to try to keep you engaged in the content. So Wally, obviously one of them, and I'm going to be nice here. Your Wally count is now 1, by the way. So little tricks. I give away prizes. Jamie does as well. Evan might, depending on what mood he's in. And the way we do that is at the end of the course, once you get that 80% competency and you pass the course, you will get an electronic copy of your certificate. You will also, in the sort of weeks following, get a hard copy of your certificate in the post, and any prizes you've won along the way will come along with that. Little bit different prizes, could be anything. We've got barrier measuring tools as prizes. We've got, I think I saw some socks floating around as prizes. So lots of random things. How do you win prizes? Well, you answer questions. You be the first to answer questions correctly. You ask really good questions, and they're pretty much the ways to do it. So 3 presenters, and as I've mentioned, myself I'm principal engineer at Safe System Solutions. So been doing that for about 9 or so years, and I started up Safe System Solutions after I left VicRoads, the Victorian government, where I was of a variety of roles, a senior road safety engineer for quite a while, manager, planning and project development, and team leader road safety, and a few other things. So I moved around a bit in the different regions and in head office. And Jamie Robinson, who you can see there, picture and on screen. Jamie started at VicRoads with me, actually, and Jamie did a variety of roles as well, but was the technical lead of traffic engineering and design. I always question whether I get that title right. Was that right, Jamie?
Near enough.
Near enough. Yeah, it was in the commercial service. So doing a lot of design work for internal design work. And one of Jamie's areas of absolute specialty was and is road safety barriers. So was that within VicRoads, and continues that along. And Evan Coulson is in VicRoads, now called the Department of Transport, and he is the manager of safe system engineering, road design and safe system engineering. Many of you may have dealt with Evan, absolute guru in barriers as well. So, and he sits on ASBAP, the Australian Safety Barrier Assessment Panel. He's the Victorian representative there. So lots of experience there, huge amount of technical knowledge. But what we've tried to do is to still this incredibly complex beast of road safety barriers down to an initial entry-level road safety barrier fundamentals course. And then we do have 2 days of, I suppose, more detailed and more, we get you out on site, actually doing a barrier design and measuring things up and facing real world challenges and those sorts of things. But that one really has to be done in person. We can give you the fundamental base through the online platform with a few different ways. So we're going to launch into this, and then hopefully in the future you'll come along to the second 2 days. And it's an entry requirement that somebody does these 2 days, does this online, or if we are able to run it in person, the fundamentals course before we jump into the 2 days, because when in those 2 days we expect a level of competency so we can jump straight into some more detailed stuff. Our contact details are all there, so please do get in contact with us. I'm probably your go-to contact if anything pops up during the course, be it technical issues or any you got any questions about the assignments or quiz questions or those sorts of things. So shoot me an email, give me a call, shoot me a text, WhatsApp, whatever you want. Thousands of possibilities of ways to get in contact with me. So we'll hand over to Jamie shortly. I just want to do a little quick bit of scene setting, but what I'm going to do is just wait a second here and see if anybody has any questions about the admin, the logistics of the course. Just jot them in now. While you have a think about that, I would like to acknowledge the traditional custodians of the different lands that we're running this training on. Pay my respects to elders past, present and emerging. And we've got a fair few lands across Victoria. So we've got everybody from Victoria except for one of our engineers from Queensland popped in to have a look. So Paul, you're going to probably scratch your head at a few Victorian nuances with road safety barriers, but enjoy. And Victoria does do few little things, different. So Richard's asked a question, and thank you, and hello to you, Richard. Will there be nominated times for breaks? Yes. If you should have got an agenda, and if not, it's in Moodle. You'll be able to find it there. But the nominated break is at 10:30, and it'll be 10:30. Might be a little bit before, but 10:30 to 10:45. You're going to have a break there. You are going to be asked, if you can, to do a short quiz in that time as well, as have a stretch and fill your coffee up and use the bathroom and all. So you've got a bit to do in that 15 minutes, but that's our nominated break time. Thank you. Excellent question. All right. So, lives lost, and we can talk about Victoria here, 2015 to 2020. You can see there, we sort of bounce around the 250 mark for people killed on our roads. Probably to the chat, guesses on the 2020. I'd love to see it right down there at 0, but unfortunately it is a bit higher than that. So let's have a few guesses in there. Just chuck anything into the chat you'd like. I've only got one guess so far, so I'll wait till we get a few more guesses come in. By the way, in the chat, and anything that's happening live is not part of your 80% mark. It's just when you get to the actual quizzes and things at the end. So there we go. You're all getting the hang of the quiz. Sorry, the chat function. That's good. Let's have a look here. 211 was the official total. So who are we going to go? Who is closest here? See, we had some, Joseph looks pretty close. It was Joseph. Well, Jamie, you can yeah, I think Joseph's our winner. Well done, Joseph. You can have a prize for keeping track of these sorts of things. Now, I'm going to write down prizes. So 211 people killed last year. So we had a year where we had a lot less travel going on, but we still had 211 people killed on Victorian roads. But let's delve into that in a bit more detail. I mean, it's a huge amount, isn't it? 200. It's an incredible amount of death. But when we add serious injuries to that, these are staggering, absolutely staggering numbers. So we see there, well, we've got 14,000 in metro and 10,000 in rural. So that's over a 5-year period there, just astronomical numbers. When you then put this to just fatal, so serious injuries in Victoria are defined as anybody who is admitted to hospital. So you can present to hospital, so they can, take you into hospital, have a look at you, patch you up, stitch you up, put you in a cast or whatever. They don't give you a bed. You're not a serious injury, right? And we see some decent injuries that aren't serious injuries, as in decent, as in the magnitude of them. But we also see some serious injuries which are recoverable. They lead a normal, healthy life. But we do also see these serious injuries down the other end of the scale, which are things like acquired brain injuries, quadriplegia, paraplegia, and just like absolute devastation of people's lives. So they're the higher end ones. And then, of course, the fatalities are the highest end of these injuries. So when we look here at fatal crashes, we see that rural represents the higher amount, but in metro, when you add serious injuries in, so I suppose a lower severity, we see that metro stands out. Pop into the chat. Why do we think that is? Just going to go on a prize frenzy here, Jamie. Yep. Okay, first answer that came in, and my little chat is only giving me Kerr. So, Kerr, you have won a prize. I'll find out who you are. I've got a username. Yes, so speed is the answer. Absolutely. Speed, it's the big influence. So there are lots of other nuances, but speed is the big one. The higher the speed, the more the damage to the human body. It's pretty simple. Breaking this down a little bit more, I'm not going to spend a lot of time on this. We see in intersections popping out for those fatal serious injuries are very high. And within the fatals, we see fixed object rollover. But if you do something which is to add fixed objects rollover and head on and call them a lane departure crash, which is what we do a lot in road safety. We refer to that as a lane departure crash. Then you'll see that would even be in fatal and serious injury higher. So leaving your lane or leaving a lane and crashing with an object, rolling over or hitting a car coming the other way or a truck coming the other way, that is our biggest source of trauma in Victoria. Now, I put in, just for your interest, head-on overtaking, and that's just trying to myth bust something that's a bit of a misconception, that all these head-on crashes we see and hear about are people making bad overtaking choices. There's a little bit of that going on, but it is nowhere near, it's very tiny compared to the head-ons where people have unintentionally drifted out of their lane or drifted into the roadside, overcorrected, and come onto the other side of the road. And just a little bit of context setting in terms of the rest of the world and how Victoria performs and the rest of Australia performs. I like this. It's getting a little bit old. It's from a few years back, but we break down road safety statistics in a variety of ways to try to get a measure of how performance is. Usually the most reliable is per 100,000 population or per million head of population. The other options are registered vehicle or per VKT. Quick prize. Person who can tell me what VKT stands for. Vehicle kilometers traveled. Kurgel, as your username says, there's on to 2 prizes. Vehicle kilometers traveled is correct. So that is the amount of exposure. So that's probably, if you have the data, your most, it's Glenn. Thank you, Glenn. If you have your data, vehicle kilometers traveled is probably your best like-for-like measure because it's the amount of movements that's happening. Like taxis have super high VKT because they're always out and about running around and exposed to more potential crashes. Motorbikes have very low VKTs because sometimes they just sit in the garage all the time and nobody rides them. So VKTs is a good measure, but so many countries are not collecting good VKT data, so you can't really often do that. Now, before I analyze this a little bit more detail, we've got a question from Debbie. According to the internet, the Victoria's current road toll for 2021 is 175. I think that's right. So we were in a slide back looking at the 2020 full year data, which is why we answered that one. And so you can get that data. There's sometimes a little bit of there's a fatality committee within government decides. There's usually a pool of crashes at the end of the year that they're making decisions as to whether they are put onto the official register of death and serious injuries on the road, or whether they are categorised in other forms such as suicide or medical reasons or the like. There's some also that if you are admitted to hospital after a road crash and you survive for 30 days and then you die on the 31st day, you are not considered a road crash victim. You are something else. So there's a few that get moved around that way. That's just a little bit of extra info for you. Okay, so let's go back to this one. Thank you for the input there. So you see Victoria does pretty well. Okay, so we've got 2016 data there, trying to actually get those full data comparisons. It's shifted slightly, but generally remains the same. And Victoria is amongst sort of the top of the world there. So a lot of credit for people doing lots of wonderful work. But this is just the top end of the world. And you see here that if we look at, this is a bit more recent, some of this data, fatalities per head of population again, and I just picked some other countries, some random countries to show the sort of distribution you've got. And you look down there at things like South Africa, Iran, Thailand, a few got picked, staggering. Libya, don't go near the roads there, that's very scary. Even the US, and you saw the vehicle kilometers traveled, they come a little bit better, but they're nowhere near performing the way they used to in the rest of the world. And we saw there that leaving the road and hitting trees or rolling over or hitting other vehicles are a huge source of trauma for us in Australia and across the world. And when a vehicle leaves the road, and if it's to strike a point source hazard, like a tree in this picture, that is the single most violent crash that we have on our network in terms of energy transfer to the road user. So even a car hitting a pedestrian has less energy transfer because the car has a bit of cushioning in different spots, and the but the tree doesn't have any of that. Side impact on a tree is an unbelievably violent event. And we know from our data from across the world and many studies that somewhere around an impact speed of 30 to 40 kilometers per hour is side impact into a tree like this one is likely to result in death of the driver if it hits driver's side, passenger if it hits passenger side. So that's pretty slow speed for impact, isn't it? Not the speed, I'm not talking about speed limit here, don't put that aside. It's the speed of impact, around that 30 to 40 kilometers, incredible. And we see power poles dotted across the roadside. We call those ones point source hazards, right? And the energy is concentrated directly into the occupants of the vehicles. And there is a bit of evidence to show also that vehicles strike it and sort of wrap around it a bit, which is extra bad. Head-on crashes. Now, these can happen at higher speeds with survivability due to crumple zone, airbags, seat belts, everything sort of kicking in. That a vehicle vehicles can crash at the data is showing us that somewhere around the 70 kilometer per hour mark. Each vehicle, closing speed of 140, is generally survivable. But above that, it gets into less survivable territory. And certainly at 100 kilometers per hour, we know there's high likelihood of death. And we don't often see head-on crashes occurring like this one, where it's a very sort of neat crash. It's often a frontal offset crash, and we get all sorts of other challenges happening. But even when vehicles don't hit things like trees or power poles or exposed culverts or other vehicles or trucks, even if they just leave the road into an open area and they start to yaw, and yawing is that sliding, and they do that because they're trying to get back on the road and overcorrect, and they start to yaw, we see that vehicles roll over. Now, this is, again, even less severe than those head-ons and the like, but it is not void of death and serious injury. We actually get a lot more serious injuries in these through spinal issues, the head bouncing around, other things in the car hitting the driver. So the thing is with this, somebody will often see a cleared roadside and think that that's wonderfully safe, like, superb. We've done everything we can. The reality is it's not at this stage, and Jamie's going to elaborate on that a little bit later. It's better than a tree-lined roadside for sure. And a cutting can even be one where we can snag, we can roll over, and so something to be aware of. Now, the old Victorian road safety strategy towards zero, and no coincidence, there was a barrier on the front of that one in the centre of the road. In fact, I took that photo when I was doing a post-opening audit with Jamie, and I were doing a post-opening audit of the Melbourne Highway upgrade there, and they popped that on the front cover. And then we see our new road safety strategy coming out, and it's still heavily promoting the use of barriers as a wonderful safe system intervention. And we've got lots of different guidance. We've got a new Austroads guide to road design part 6, roadside design, safety and barriers, which has recently been released. We've got now the manual for assessing safety hardware, or MASH, as you might have heard the term, which is the test protocol. Evan's going to take you through that in detail in terms of the crash tests and what we can expect out of barrier systems. We operate our philosophy in road safety across Victoria using the safe system approach. Now, the safe system approach is something you're all pretty aware of, I'm sure, so I'm not going to spend time on it, but just to contextualize barriers into this safe system approach. When we say people are going to make mistakes, that's a principle of the safe system. That means they are going to leave their lane. They're going to fall asleep. They're going to text. They're going to turn around and scream at the kid. They're going to drop their coffee in their lap. An animal's going to jump out on the road. They're going to, you name it, it's going to happen out there, right? Now, you can get angry at that. You can stomp around saying they shouldn't be driving, whatever it is. But the reality is it's going to continue. And if we ignore it or we blame, we're not going to solve this. We might be able to reduce it a bit by, with enforcement and education. But the reality is we need our system to cater for those mistakes. And one of the absolute best things we've got out there to cater for mistakes is a barrier system, because it does not care whether you were drunk, whether you were speeding, whether you're speeding, I'm going to put a little asterisk on that, because barriers are sort of designed for different speeds and the like. But, whether you're drunk, whether you fell asleep, whether you drop coffee in your lap, it is the vehicle leaves the road, the infrastructure forgives, and means that we keep things within human tolerance to physical force. So we direct energy and dissipate it over time along the barrier. And we've just had a massive win. And it's so aligned with Safe System because it takes this shared responsibility and says, yeah, we don't want you to drive when you're tired. But if you do, we're gonna try to protect you. But we're not saying do it, and we're going to do everything we can to stop people driving tired. But we're also taking some responsibility as well, and it sits squarely within our safer roads element of the Safe System. Okay, so I just a bit of context setting. I think a lot of stuff you probably already knew there. Hopefully you found a few things interesting. I'll take any questions. The US, yes, they did. The only column they appeared in was the vehicle kilometers traveled, and that's always I did work for a little bit of time in the US, and that was always one of their things. Oh, you can't compare us to any other country because we do way more driving. We have way more exposure to crashes, so that's why we have higher crash rates. And when you do it by VK2, they're still not performing well. They perform a bit better. Okay, so that was a bit of scene setting. I'm going to hand it over now to Jamie. I've given you why barriers are so important from that high level context. They're an integral part of our road safety strategy. We're going to roll a hell of a lot more out over the coming decade. And for us, what we want to do is ensure that we get best bang for our buck with those barrier systems, and also to ensure that we're not introducing any hazards into the roadside by incorrectly installed, designed, or maintained barrier systems. And so that's what we're going to jump into. And Jamie's going to take you through a bit of the sort of fundamental thinkings around roadsides, and then a little bit into barrier design. And then at 10:30, we're going to have a break. Then after that, Evan's going to come in and talk to you about different products and about what you can expect out of different products, and all the barrier systems, the end terminals, the crash attenuators, and all sorts of goodness. So, but I'm going to drift into the background now, and but I will be monitoring the chat and answering questions and feeding questions to Jamie. And I may pop in randomly, Jamie, and depending on how we're going, do a little quiz or ask a question, or maybe even play a little video depending on how time's going.
Sounds good. Thanks, Ken. Oh, can you please enable my screen sharing?
That will help. So, sorry, bear with me a second. I try that now. That's looking good. Hazard identification.
Right.
And we can see that. And I can't see your mouse on there, but yeah, there it is. Beauty. Good to go, Jamie.
Thank you, Ken, and good morning, everyone. So yes, I would like to talk about hazard identification. So identifying the hazards that are present on our roadside, but really this presentation is more about risk assessment and risk determination, because every roadside does present a level of risk, regardless of whether some of those point source hazards that Ken mentioned are present or not. Some of the key references when it comes to hazard identification and all things barriers actually are the Guide to Road Design Part 6. Now, that was recently updated about a year ago. Some parts of the document were updated, and particularly those around risk assessment, to bring it more into line with safe system thinking and to address some issues around clear zones and the like. Each state, and particularly Victoria, has a lot of supplementary guidance that supersedes the Austroads Guide. So there's a Vic Road supplement there to the Austroads Guide to Road Design Part 6. So always refer to that supplement if you are looking to the Austroads Guide. In addition to that, each state, and again, particularly Victoria, has a lot of supplementary stuff around barriers, and Vic Roads, or DOT I should say, has recently consolidated some of its guidance into this Road Design Note 0616. So if you're up for a bit of light reading, I encourage you to have a look at that one. Now, as I say, every roadside does present a level of risk. Obviously, there are some things that contribute to the level of risk on a roadside, around hazards, the type of hazard, how close they are to the edge of the road and so on, the speeds of vehicles on that particular road, the volume of vehicles on that road, which is around exposure, the potential for side impacts with hazards, increases the severity and the risk, and all those little factors that contribute to the likelihood of vehicles departing the road, delineation, curvature, interactions at intersections, and all those other things. So I will talk shortly about a new approach to assessing roadside risk that has appeared in that Austroads Guide. And the object of any design in accordance with the Austroads Guide should be to ensure that the level of roadside risk is as low as practical. In the past, we have used the clear zone concept, and I'm sure you've all heard that term. The clear zone concept really is outdated. It's old hat thinking now. It was based on some research that was undertaken in the United States in about the 60s, where some vehicle paths in snow were measured, and the distance that errant vehicles travelled from the edge of the roadside were measured, and that was the source of the old clear zone thinking. So obviously, with advances in vehicle technologies and speeds and so on, and simply the different conditions that we encounter in Australia and around the world, that theory and research is no longer particularly relevant. And with the acceptance of the safe system approach, it's no longer acceptable to assume that by protecting everything within the old clear zone distances that we're doing enough. The safe system approach seeks to eliminate deaths and serious injuries. The clear zone distances that we used to adopt really were a balance between economics and the cost of providing that clear area, and providing enough space or some space for most errant vehicles to come to a stop before reaching a hazard. And the distances that we're talking about there in high-speed environments was something like 9 metres. In lower speed environments, we would go with less. So please forget about clear zones. It's no longer appropriate. We do know that 15 to 20% of vehicles will travel beyond the distances that we used to consider in our clear zone approach. That's not to say that providing a clear zone doesn't have benefit. It does, but please don't think that by providing a clear zone, you're doing as much as you can. You're certainly not achieving safe system outcomes. So we refer to clear zones now as supporting treatments in the safe system treatment hierarchy. Primary treatments are what we should aspire to. They are the treatments that do eliminate deaths and serious injuries associated with certain crash types. And flexible safety barriers certainly are a primary treatment for addressing lane departure crashes. But as I say, some clear zone is better than none. So if providing continuous barrier is not an option, and it often isn't, then providing a clear area adjacent to the road might be a good option. These are all quotes from the Austroads Guide to Part 6. And the bottom one there is an interesting one. Clear zones should be regarded as having the potential to be a hazard in their own right. Now, that statement relates to the potential for rollover crashes, which can occur even when we do have a relatively clear flat area adjacent to the road. We know that vehicles can and do roll over. It's very difficult to achieve a uniform, flat, well-compacted surface throughout the year in all weather conditions that doesn't or that will not cause a vehicle to roll. Often when vehicles depart the road, there's corrections and drivers turn sharply, the wheels create a divot, enough to grab the vehicle and make it flip and roll. So message there, we're not doing clear zones anymore, and shortly I will introduce you to the new approach to assessing roadside risk. The picture there shows what might have previously been thought of as an ideal roadside, with nice, relatively flat, clear areas adjacent to the road that would allow an errant vehicle to come to a stop before reaching a hazard. That level of road has a good level of safety, but it certainly doesn't eliminate the possibility of vehicles striking hazards located beyond clear zones, of rolling and serious injuries and fatalities as a result of rollover crashes and even cross carriageway crashes. So we now use a term area of interest. And there have been a number of pieces of research that have looked into area of interest, and they've all converged on about the same numbers. Now, the area of interest is essentially any or includes any and all locations that an errant vehicle could feasibly reach when it departs the road. So to achieve safe system outcomes, we would want to provide, ensure that our area of interest is entirely free of point hazards and is traversable and well compacted and so on, so that it doesn't result in rollover. And the distances that we're talking about are huge, 40, 50 and 60 metres in high-speed environments, which is clearly not feasible in most or all situations. Speed really is key in lower speed environments. Our area of interest is much less, and there's obviously a much lower potential for serious and fatal crashes at lower speeds in the order of 60 and 70 kilometres per hour. We know that head-on crashes with other vehicles and point hazards are unlikely to result in serious and fatal outcomes at those speeds. But there is that possibility of serious and fatal crashes with those side-on impacts at intersections, or perhaps run-off road crashes where the vehicle strikes a hazard side-on. So please keep these numbers in mind, which are clearly much higher than the old clear zone numbers, and really make the provision of safety barriers and continuous barriers, as we're increasingly doing, a much more attractive option. This is a little snip from the Austroads Guide, Part 6, around lateral distances and the effect that fill batters can have on those distances. So a fill batter being one that slopes down as you travel away from the road. There's been a little bit of adjustment in thinking around slopes that are considered to present hazards in their own right. So the top image there, we have a relatively flat embankment slope of 6:1 or flatter. If we have a batter slope that's 6:1 or flatter, it's considered traversable and drivable. If you depart the road, it's likely that you'll be able to correct your vehicle path and steer back towards the road and not strike a hazard such as a tree if you're alert and able to do so. If the batter steepens up above or steeper than 6:1, it's likely that an errant vehicle will travel to the toe of that batter and beyond. So we basically ignore the width of that batter in our lateral distance assessment. So we have a distance A plus a distance B between the toe of the batter and the nearest hazard that we need to consider as our lateral distance to the hazard. When our embankment steepens up to steeper than 4:1, the embankment is considered to be a hazard in its own right. A vehicle is likely to roll on that batter or is much more likely to travel beyond the toe and strike a hazard beyond the batter. So really an equivalent cross-section to the one at the bottom would be one with trees at the hinge point. I can.
Questions come in, and so you're highlighting the hazard of trees there, and the questions around why are we then planting trees in the roadsides and median? Yeah, hazard.
We often do like to plant trees in our roadsides. Look, speed really is key. DOT has some guidelines around boulevard plantings, and we certainly do it in lower speed environments, 60 and perhaps even 70 kilometres per hour. If we're in a speed environment higher than that, certainly we shouldn't be doing it unless we're looking to provide barrier protection from those hazards.
Yeah, I think that's right. I mean, managing the road environment's complex beast, and the environmental benefits and aesthetic benefits, and there's lots of benefits to trees and the like. And what we need to do is ensure that they're being done at low risk. And Jamie's spot on there. There used to be a time though where you'd calculate your clear zone. And Jamie will talk to you about that. But if you calculate 9 meters, and then often it would be planting of a run of trees at 9.1. And because you wanted your trees and your vegetation, and that was somehow considered safe. We know now that is safer than having it at 5 meters or 2 meters off edge line. But certainly, if you're going to be doing that, a barrier system in those high speed environments. But there's a lot packed into that one question. So a good question. Thank you for popping it in.
Thanks, Ken. Any further questions before we move on?
No, just some comments about other reasons why trees would often go in canopy targets and other bits and pieces.
The Austroads Guide to Road Design Part 6 includes a new roadside risk assessment process which supersedes the old clear zone approach. There are some common elements to the two processes. Clearly, distance from the edge of the road is an important consideration, but there is a lot more to consider when you're thinking about roadside risk. So the process uses a fairly typical risk assessment process of exposure and likelihood and severity of risk. And the output of the process is a risk score rather than a distance, as per the clear zone approach. So the risk scores are numbers, low numbers, sort of from 0 to perhaps 5 or 7 or 9. and might typically fall in the range of sort of 1, 2, and 3. There's a term that's a bit of a mouthful called the Network Roadside Risk Intervention Threshold. So there is the potential, and the idea is that jurisdictions will set levels, risk levels above which we should intervene and treat roadsides with barriers or other treatments. This is a work in progress. South Australia, I think, has made some good progress and set an NRRIT of 2 for certain situations. It's not a one-size-fits-all approach, and Victoria is looking at this now, and I expect that there will be a number of different risk levels set for different road environments and situations. So stay tuned for that. Another snip from the guide that just around that process of setting the NRRIT. So in order to come up with a score, a process is set out where you need to assess the hazards along a road. It talks about background and isolated hazards. Background hazards are those that are consistent and continuous. So all roads have a background hazard. That hazard may be sort of as forgiving as a clear roadside, and the risk is purely a rollover risk. The background hazard might be some other longitudinal hazard that has a greater risk, perhaps a row of trees. And if those trees are located closer than 20 metres apart, the likelihood is that you won't be able to pass through a gap when you're leaving the road at speed. A batter is another type of background hazard, as is a fence along a property boundary. By contrast, an isolated hazard is an intermittent hazard or an occasional hazard located in front of the background hazard. So it might be a tree or a pole located closer to the road than a batter behind it. And in its own right, that isolated hazard perhaps presents a greater risk due to being closer to the road and being a point source hazard. So if those isolated hazards are close together, again, they should be considered as a background hazard. And the assumption is that if a vehicle doesn't collide with an isolated hazard, they'll continue further from the edge of the road and will reach the background hazard. So there's this differentiation of background and isolated hazards that we need to make. In the image here, we could perhaps say that there is a background row of trees sort of back near the edge of the road reserve, probably on both sides, and then nearer to the road there are some isolated trees. There's a big one there and one there that are clearly closer to the road than that background row of trees that, you know, at a fairly consistent offset. In an urban environment such as this one, the background hazard would be the fence. We can see a fence with some brick columns here that might be a snagging hazard to an errant vehicle. And in front of that, we have a tree, we have some signal pedestals, some utility poles further down the road. So they are our isolated hazards in this situation. So the guide sets out a risk assessment process, and there are 2 ways of going about it. There's a simplified process that I'll introduce you to now, which uses risk score charts to determine risk scores. There are a whole series of risk score charts, I'm not sure, 20 or 30 or thereabouts. And the intention is that you can choose the chart that best represents the roadside conditions for your particular situation. So in most cases, it is appropriate to choose the chart that best fits your situation. If, however, you find that your road environment just doesn't fit with the charts that are provided, you can sort of do a first principles assessment using a process set out in an appendix to the guide. But I'll introduce you to the process now. We won't go into a lot of detail. We do that in the applications course, the 2-day course. So really, I'll treat this as a bit of an intro. There are some of the charts. You can see a series of charts there for undivided rural roads with significant background hazards. So these charts are for a rural road with only background hazards, no isolated hazards. You can see on the horizontal axis is AADT, so traffic volume, affects our exposure and is a critical factor. We need to choose the chart that is appropriate to our terrain. You can see across the top there we have mountainous, rolling terrain, different speeds at play as well, 70, 90 and 110. So there's lots of different combinations and permutations of speeds, terrain, and rural or urban environment, and combinations of hazard. So we need to look to the chart that best suits our situation. So if we had a rural environment with a rolling terrain and high speeds, perhaps in the order of 110 kilometres per hour, we'd be looking at this chart number 3 at the top right. If we did a quick example, if we had 2,000 vehicles per day using that road and our background hazards were at about 7 metres, I hope you can see my cursor there, from 2,000 vehicles per day up to the purple line, which represents our 7-metre hazard offset. We reach this point. If I read across to the vertical axis, we've got a risk score there of about 3. So you can see when looking at the series of charts at the top there, the increase in risk score, or the magnitude of the increase of risk score as speed increases, and or particularly as speed increases from left to right, 70, 90 and 110 kilometres per hour. There are a few more charts. In this case, these charts represent divided urban roads with background hazards only. So there's a little bit to get your head around there. You need to be a little careful that you're looking at the correct chart or the most appropriate chart. And again, you can see a clear correlation between the increase in speed and risk score. Any questions?
Thanks, Jamie. I was just popping a few things in there. There's a good question from Glenn around whether the charts are used for individual locations or at a program level. And I sort of answered, I've only ever seen them used at an individual level. I've never seen them used at a program level. But then I thought, oh, well, you could probably set a network roadside risk intervention threshold for a program. And say you decided, for the Hume and the, Calder and the, for the big roads, you'd do a 1.1 or something as your NRRIT score. So that could be at a program level, and it would just alter where on the graphs you're looking at different hazards. But have I got anything you want to add to that?
I think you're right. For high-speed, high-volume roads, there are cases where the level of risk is going to exceed any threshold that's set, and the clear response would be install continuous barriers, and we've been doing that on the roads like the Hume and the Calder and so on. But for a lot of roads, the level of risk varies along the route. The risk is increased at curves, in particular. and there's provision in this approach to factor up the risk score based on curvature and also grades. So look, the risk scores should be, for most roads, I'd suggest we need to be looking at individual locations, and it is possible to break down a length of road into sections based on their typical characteristics, and you'll find that the level of risk does sort of go up and down as you drive along that road. So it might be that some sections of the road might warrant treatment and others don't.
Yeah, absolutely. And I suppose the little thing to add into that is that the NRRIT or these risk charts actually account for volume. So we're talking about the human, the colder and things like that. So the volume is sort of taken into account into the risk scoring. However, it's more that we see these as the strategic routes and where we're going to be trying to push traffic and keep speeds high and the like. So there's a strategic element to that. It's not that we picked those routes because they were high risk because of the volume, because that's already accounted for in that. Next question has come in around who's setting this NRRIT for the program, TAC, DOT, or the like. And that's probably one we might transfer over to Evan, because he's really the person who's going to have to be setting them for Victoria, as in his team will have to be setting it for Victoria. And we wait with bated breath for him to give us some numbers. I think, as you said, South Australia's jumped ahead and popped out the number 2 to cover the whole state. Queensland's done some forward thinking on it, but Victoria hasn't yet presented it. There's work going on in the background. But I will make a note to ask Evan that question in the session later this morning.
Right, so look, that really was very introductory, I acknowledge. Perhaps has raised more questions than it's answered, but look, this is an emerging process and practice that is starting to be used and will be used increasingly to assess roadside risk. And when we do have that guidance around NRRIT, it'll be all the clearer.
Sorry, I was just going to say, Jamie, I mean, without an NRRIT, so, without that being set, I still find these charts quite useful in roadside sort of hazard management, as you've mentioned and you've alluded to, because if you've got a road that you're working on, you can utilize these charts to tell you which are the highest risk bits of it, how changing the speed would influence it, or if you go into different speed zones and the different hazards on the roadside. So you can compare the risk between a steep batter and a tree at a close offset based on the volume, the speed, and just going to different charts and finding out what risk score they produce. So you don't need to know, because then you can sort of make decisions of how much money do you have for this project, and then be working through the highest risk roadside with barrier systems or altering hazards one way or another, driving culvert end walls, or these sorts of things. So it's a nice risk assessment methodology. The only thing we're missing at the moment is the line where we say this is acceptable risk and this is not acceptable risk. We don't have that at this stage.
Yeah, it's a great tool for I guess prioritizing spending. If you've got a limited bucket of money and in the absence of an NRRIT value, you can assess a length of road and work down a list of ranked of locations ranked by risk. Treat the highest risk first, and so on.
Now, another one just clarifying on that was asking, is it only barriers and slowing speeds that are seen as safety measures, or are there other interventions?
No, there's certainly plenty of other interventions. We talk about barriers being primary safe system treatment. And look, they are the sort of the safety net, I guess. There are lots of things on any road that we should be doing to reduce the likelihood of people departing the road in the first place through good delineation. And there are lots of different ways that you can do that. Education programs to address fatigue and drink driving and all these types of things.
Oh, I might have just lost Jamie there. I'll continue for a second here. Just as he was saying there, many interventions. So yeah, we've got delineation. So that's all our signs, our line marking. We've got sealed shoulders, audio tactile edge line. Yes, barriers are wonderful, and there are sort of the best for passenger vehicles and often larger vehicles. But we've also got, if you do have a point source hazard close to the road, a power pole, a tree or the like, if that could be removed, that will lessen the risk. As I say, putting a barrier system would be better. You'll get a better outcome if you put a barrier system. But we've got different options available to us, and that's just the tip of the iceberg. There's a huge amount more. So good question. The roadside risk intervention thresholds, you're going to have a look at that in part 6 yourself. Jamie's just given a very high level, but there's heaps of those charts, and you can, look, okay, it's this type of road, it's got these features, it's this volume, it's this speed, and okay, it's got a risk score of that. And you can then go through and find another chart, which will give you another risk score. A roads risk, so I'm reading another question. A roads risk should be what the average speed people can actually driving at, regardless of the actual speed limit, also taking into account the roadside inherent risks as well. So yeah, it's a really good point there from Debbie around what speed do we pick to make decisions around, and we very much pick operating speed. So speed limit often is an indication to us what we think operating speeds might be, but if you can get operating speeds, you're in a far better position to make these calls. And certainly we know some areas that have lower speed limits but much higher operating speeds, and we should be taking that into account. So motorcycles, I have a dedicated session on motorcycle safety coming up, so I will address that, and we do sort of say, we make broad statements around things like this is a primary treatment and the like. We're usually talking for passenger vehicles. The overwhelming, like far and away the overwhelming source of trauma on the roads of Australia are passenger vehicles leaving the roads, hitting with each other and hitting the roadside. There is a portion of motorcycle trauma with leaving the road. There's a portion of other trauma, so with other vehicles. And so we're going to address that a little bit in some later modules, but it's a great question. I've got you back, Jamie, but I'm just answering a few questions that have been coming in, so timing was all good. So these charts assume the terrain is flat. However, there is no sufficient space outside the traffic lane, and batter slopes are steeper than 1/4. Does it mean that the risk score will increase significantly, and if so, by how much? Well, the charts have batter slope as well. There are well, sorry, that goes back to your other one, doesn't it, Jamie? I'll let you explain that.
So there are charts for different terrain types, flat, rolling, and mountainous.
Yeah, but sorry, that cartoon style picture you had with the batter, if it's a significantly steep batter, you just take it out of the calculation from offset from hazard. So it's basically right. Like that steep bit doesn't exist in terms of offset from edgeline.
Your offset to your hazard is to the hinge point. So it's whatever that might be. So it could be a tree at that location, it could be that steep batter. yeah, so that's it. Your lateral offset is just that to the hinge point.
Yeah.
Where the batter falls within that 4 to 6 to 6 to 1 range, we need to ignore the width of the batter and add the two components, the width to the hinge point and then the width from the toe of the batter to a point hazard.
Yep. And I suggest people jump into the PDFs of the slides, which are on your memory stick and in Moodle, and jump back to that diagram that Jamie showed probably 6 or 7 slides back with the cartoon trees and that sort of explains that concept really well. Good. Thank you for the questions, everybody. They're coming through nicely. Jamie's back onto the slides on screen, so we're doing beautifully, and we'll let you continue, Jamie.
Thanks, Ken. Sorry about that, guys. The internet dropped out on me. So the assessment of hazards can be a little bit subjective. The new guide makes it less subjective. Hazards are now categorised according to trauma indices. So they give each hazard a trauma index based on the level of severity of, or the expected level of severity of an impact. And hazards are categorised by those trauma indices into significant hazards and less significant hazards and minor hazards. So the significant hazards are those with the greatest trauma index, and they include trees and other hazards where the trauma outcome is likely to be comparable to someone striking a tree. So we have trees, utility poles, fixed base light poles, traffic signal poles, fixed objects protruding above the ground by a certain amount, batters that fall into certain slopes and heights. So we have a little bit more definition around batters that constitute hazards or significant hazards, vertical drops and watercourses and so on. So the list of hazards here are those that are considered to be the most severe and therefore you should look at treating first. So I'll step through some examples of some of those key hazards that fall into that significant hazard category. And obviously trees are the big one. MUARC in Melbourne has done a lot of research around this and have found that of serious single vehicle run-off-road crashes, 87% of the serious crashes resulted from someone striking a fixed object. So there are 13% left over that are rollovers, maybe some violent spins and so on. But 87% of serious single vehicle crashes involve the vehicle striking an object. 55% of the time, that object is a tree or a utility pole. So trees and poles really are the big killer. Austroads includes a definition for how big a tree needs to be in order to constitute a hazard. No wonder if someone can give me the magic number. So we're talking tree diameter. So the first person to pop in the magic number into the chat might get a prize, Ken.
Yep, Jay. Yes, add to the prizes. So we've got 150, 70 to 100, 100, 150 to 200, 75, they're coming in.
I believe it's 100 mil. So if a tree is greater than 100 mil in diameter, and I think that's measured at breast height, yep, then it's considered a hazard in accordance with Austroads.
Yep, it is 100. That's right. So, and I'm going to give 2 prizes out there because 2 people got the 100 right on the 100 in before the answer was said, and so that's Paul and Priscilla. So 2 prizes there.
So trees and poles are the big killers. Most serious crashes with trees occur in rural environments. Most serious crashes with poles occur in built-up environments. And there we have, a lot of the time it's those side impact crashes that do result in those serious crashes, even at relatively low speeds. The assessment of trees can be a subjective thing. We talked about the 100 mil rule. These trees, and I think they're melaleucas, are located on the South Gippsland Highway south of Melbourne. A project was undertaken to install isolated barriers along this road to shield trees and poles and other hazards. The decision was made not to shield this stand of trees and all trees of this particular type along this road because it was deemed that they were frangible. To my eye, there were trunks that were greater than 100 mil in diameter and numerous trunks that might be struck at once. That was the decision that was made. Interestingly, this road has been treated again since, and continuous barriers have been installed through this location to shield these trees and every other lane departure possibility, rollover, cross carriageway crashes, and crashes with objects beyond the clear zone and so on. So as we all know, interfering with trees at the roadside can be a sensitive issue. So it's probably rarely the case that we can remove trees. Putting barriers in front of trees presents issues often in terms of achieving space for deflection, possibly damaging tree roots when we're installing barrier posts.
And Jamie, on that one, if you were having a look at that site today, what would be different from back in 10 years ago, whenever it was that you were looking at it?
Yeah, and it probably was about that long ago, Ken, and the approach then was to install isolated barriers to shield specific hazards. And the approach was to locate those barriers as far from the road as possible to maximise the recovery area for errant vehicles, but primarily to minimise the length of those barriers. So we were looking to put in as little barrier as possible. So your barrier offset from the edge of the road was really driven by the deflection requirement of the system. So you'd work backwards from the hazard. And if the system needed 1.5 meters for deflection, you'd put the barrier 1.5 meters away from the hazard. And the offset was what it was. So you ended up with some pretty strange combinations of offsets, barriers stepping in and out as you went along the road. Whereas now the approach that is taken when we're installing continuous barriers is to adopt a consistent and preferred offset. 4 meters is nice to have. So the approach really has changed a lot in a small number of years.
Yeah, so there's a couple of points sort of coming in around the importance of vegetation. And I think, really with our current barrier philosophy and native vegetation, we're in a real win-win, as I mentioned in there before, because a continuous barrier system there, as long as you've got appropriate deflection space, you can keep as much vegetation sort of as you want in there. So you've got a real win-win there. Paul's then sort of asked, well, does the type of tree matter, different tree species and the like? Now, I'm not sure whether he's referring there to whether or not it can be removed or not, or whether it's going to be more friendly to being struck, as in more sort of rubbery. Actually, there are rubber trees, aren't there? But no, I don't think they would be different. I commissioned a study quite a while back now, about 15 years ago, when I was in the road safety department, to try to determine if there was any vegetation we could installing the roadside that would act as a barrier as such in terms of dampening the energy of a vehicle leaving the road, slow it down in a nice friendly manner. And so we've got a sort of juicy research report on that. The conclusions were sort of, in theory, it can be done, but the practical realities of it are quite hard to do, for the sense that your maintenance of that is very hard to do. It could grow stronger. Also, if vehicles leave the road and they hit it, it takes a very long time for it to grow back. So you're losing that effect. Yeah, so there was also thinking about motorcyclists and the fact that we know that it's a far more hazardous way to treat a roadside than a barrier system in its own right. So in the end, it wasn't really preferred, but in theory, it could happen. Now, there's a little bit more chatter going on. Jamie, I'll let you continue, and I'll just read through this and try and work out where we need to get your input.
So talked about trees. Poles really are in the same category as trees. They're essentially a tree trunk without the foliage, and we often see serious and fatal crashes with poles. In some cases, they're located close to the road. They're often located in quite inconvenient locations near intersections where the run-off road crash risk is increased, and also it's particularly difficult to shield them with a longitudinal safety barrier. Here we can see a road with a series of power poles located quite close to the road, sort of within 4 meters or thereabouts. Lots of driveways and access points, and you can see a series of short guard fence installations to shield some of those. Others in the foreground, for whatever reason, are not shielded at all. Perhaps this one falls just outside the 100k zone, and that was the justification. Others are located near access points, and these rapid crash cushions have been used which is sometimes done as a last resort rather than a do nothing. They're really not appropriate for such a high-speed environment, but offer some level of benefit. So look, power poles really do present some challenges on our roadsides. It's very expensive to underground or relocate them. So often we do resort to putting in barriers. And when there's lots of constraints like this, our barrier solutions often end up looking a bit unusual. This is not a power pole, but a rigid light pole, and I'm not sure which went in first, the pole or the guard fence. But that's not a great situation. I would argue that the presence of the guard fence is actually increasing the risk presented by that pole, because someone that strikes the guard fence is likely to be redirected along the rail and into the pole. So wherever possible, we should be installing frangible light poles. And if we do have to provide a rigid pole located as far from the road as possible, and preferably behind a barrier, not in front. Gantry and cantilever sign supports traditionally were located such that the column was outside the clear zone, which might have been sort of 11 meters or thereabouts on a divided freeway like this. With safe system thinking and doing away with clear zones, we're now seeking to protect those, which means that in many cases they're located closer to the carriageway and signs more visible. These columns are significant hazards. You don't want to be striking one of those, and there is also the potential for a secondary consequence if that structure was to be struck by a heavy vehicle and topple over onto the carriageway. There is potential for greater consequences than just that single vehicle crash. On Eastlink in Melbourne, a barrier was installed in front of this gantry, but it's a wire rope and an old wire rope system that would never have been expected to contain this truck. The truck has penetrated the barrier, struck the gantry support with catastrophic results. Fortunately, the structure didn't end up on the carriageway, or things may have been even worse. It is important that a higher level of containment is afforded to objects like this on our roadside, where there is that possibility of the structure coming down onto the road or some other type of secondary event happening. So Vic Roads now has some guidance around providing barriers for sign support such as this, and the likelihood is that that sign would now be protected with a concrete barrier. There's a whole range of drainage-related hazards that we see along our roadsides, and they include exposed culvert end walls like this one. This is not one that you'd look to install a barrier in front of necessarily. You've got an access point that you'd need to maintain. The typical treatment there would be to simply replace that concrete wing wall with a drivable end wall type. Here in a median, we have a divided road with transverse culverts. We have a bit of a drop off there and some exposed head walls. A barrier on one side. We could install a barrier on the other side, on the left side of picture. Alternatively, we might look to pipe between those and install a pit at the junction perhaps, and backfill to make a drivable surface. Here's a small structure located on a road that I was involved with that had a high runoff road crash history. It probably doesn't fall into the significant hazard category. If you recall, a vertical drop needed to be greater than 2 metres to constitute a significant hazard. This one's probably not quite that, but the decision on this project was made to install a barrier across this structure. Doing that often presents challenges. You can see there's very limited depth for the embedment of barrier posts. So the solution here was to provide a ground beam, so a concrete footing for the barrier system that spans the length of that structure. At the time, it was required to have a custom design done for that treatment. These days, the barrier suppliers have some off-the-shelf designs for ground beams for this type of situation. Fill batters may be hazards in their own right. We talked earlier about the consideration of fill batters in the calculation of lateral offset to hazards. So again, if we're flatter than 6:1, the batter is considered to be recoverable, meaning that you can recover your vehicle back towards the road. Steeper than 6:1, the distance from the edge of the road that an errant vehicle will travel will increase. Steeper than 4:1, the batter should be considered a hazard in its own right and treated in some way. That might mean installing a barrier on the shoulder or verge. It might mean flattening the batter if that's a possibility. Cut batters have been particularly subjective in terms of assessing their risk. Austroads provides a little bit of general guidance around the assessment of cut batters. Obviously, the face of the cut batter is an important consideration. If it's a smooth face, there's a school of thought that the cut batter will act as a rigid barrier and redirect an errant vehicle. However, if the face of the cut batter is jagged and may snag an errant vehicle, then the level of risk certainly is much higher. The slope of a cut batter is a consideration, and Ostrodes talks about batters of 4-1 or steeper constituting a hazard, particularly a sort of snagging hazard on striking the batter, or a rollover risk if you reach the batter and drive up it. In the image here, we can see a cut batter, the back slope. Another important consideration is if there is a table drain at the base of that cut batter, what is the slope combination between the foreslope and the back slope? So this change in direction at the invert of the table drain, if that is too severe, an errant vehicle is likely to snag in that drain. And Ostrodes does provide some guidance around preferred cross sections for drains such as this. So I encourage you to look to that when you're dealing with cut batters and table drain cross sections. There's a cut batter with a rocky face, a table drain at the base of the batter. You wouldn't want to run off the road there. You'd likely snag in that drain or on the face of the batter. It is a relatively low volume rural road, obviously very constrained in terms of available width. So there is a hazard there. It is on the inside of the curve, which there is a reduced likelihood of lane departures on the inside of curve. To install a barrier at this location would mean the barrier would need to be very close to the edge of the road. It may compromise sight lines due to the curve. There'd be very little recovery area for an errant vehicle. It would probably be subject to frequent nuisance hits. So installing a barrier at this location is probably more trouble than it's worth. Here's another location just a bit further up the road. It's a smoother batter face, again located on the inside of curve, so the risk is probably reduced. You've got a curb at play here, and there are some rules and guidance around locating barriers in relation to curbs that we'll talk a bit more about on Friday. So again, here on balance, this is not a hazard that you would look to shield. If this batter was on a high speed, high volume freeway, we may well look to shield it. And that has been the case on roads such as the Hume Freeway and the Calder Freeway near Melbourne. It typically is the case where we've got a cut batter that we do have a curb in place. So that's a complicating factor. There's often not sufficient space between the curb and the toe of the batter to accommodate the barrier deflection. So we need to think about how we address that. Do we stiffen up the barrier system? Does it affect our choice of barrier system? Do we entertain the idea of modifying the batter to achieve a wider verge? So cut batters, when they're decided to be, when it's decided to shield them, do present their fair share of challenges. They can be deceiving. I need the before photo here, but this was a relatively uniform, nicely grassed cut batter. But the surface was soft and soft enough to snag that errant vehicle when it struck and cause it to roll. The next category of hazard is referred to as less significant hazards. So these are this category of hazard has a lower have lower trauma indices than significant hazards. So we've got slip base, frangible sort of light poles and the like, some less severe batters, objects protruding a little above the surface. I think in the significant category, we talked about the protruding 300 millimeters or more, so enough to snag the underside of an errant vehicle. Slopes and so on. So the risk assessment process, if you're doing it from first principles, does assign some factors to hazards within these categories as well. And I guess they're built into the charts. So there is a distinction made between the different types of hazards. Within the less significant hazard category, a subset of that category is the category of minor hazards. So there we have some even gentler batters, shallow watercourses, and some minor slopes. So they have lower trauma indices again. An impact with these is likely to be, but still likely more severe than an impact with a safety barrier. This table appears in the guide and is a useful way to compare hazards across the three different categories. You can look to, if you're dealing with a batter, you can sort of quickly and easily refer to the fill batter section, which I'm sort of pointing to here, and see which of the three categories your particular batter might fall into. Now, I will say that those three categories of hazards, the assessment of those hazards is primarily based on the risk to the occupants of passenger vehicles. There are objects that may not be considered significant to the occupants of passenger vehicles, but certainly are to motorcycle riders. And they include some small sign support posts, so sign supports that are typically considered frangible. They are not to motorcyclists, so it is important to consider some more forgiving sign support types in locations where we know that motorcyclists are particularly vulnerable to coming off their bikes. Slip base light poles, for instance, are not frangible to motorcyclists. Trees of a smaller diameter than the 100 mil that we talked about before, maybe a hazard to motorcyclists. And the photo here shows a number of those things happening. We've got a slip base light pole, a small tree, lots of signs, and we do know that motorcyclists are vulnerable to coming off their bikes or entering roundabouts at excessive speed and ending up in the central island. So we often look to provide some more forgiving sign support signs, hazard marker signs like this within roundabouts. That might be a location where you would consider doing something specific to motorcyclists. I'll also point out that the list of hazards probably doesn't particularly apply, or it doesn't apply in the same way to the occupants of heavy vehicles due to their greater mass and stiffer construction. They often do present less risk to the occupants of heavy vehicles. And we know that single vehicle, heavy vehicle run-off road crashes do rarely result in fatal and serious outcomes when the crash involves striking one of those objects. The question was raised earlier about treatment options. This list here, it isn't arranged in sort of, in sort of a hierarchy order. The previous version of the Austroads guide did do it that way, and barriers was basically at the bottom of the list. The hierarchy was to eliminate the hazard or treat the hazard in some way before considering barriers. Now I'd suggest that barriers is, in a lot of cases, your first treatment option. But as the guide says there, a combination of treatments is required. A barrier shouldn't be used on its own to treat some other underlying issue with the road. So there might be issues that can be addressed by improving delineation, providing audio tactile edge lines, for instance. The cross-section might be deficient in some way, lane widths. We still should look at opportunities to remove hazards and relocate hazards in certain situations. Again, the wording in the Austroads guide has changed around the use of barriers, and it is now talked about as a preferred treatment. And again, there, I'm quoting the Austroads guide. It's the primary method of mitigating risk due to vehicles leaving travel lanes. The guide still does acknowledge that barriers should only be installed where the barrier reduces the risk associated with the roadside. So we do need to be mindful that barriers can introduce a risk to road users, especially if the type of barrier is not one that is currently accepted for use, or the design is inadequate. It might be that we're locating a terminal in a location that is particularly likely to be struck. The terminals are the most hazardous part of the barrier system, even though they're crash tested to certain levels. There are lots of different moving parts and variables that when we're talking about vehicle strikes with terminals, and it's something that we should try and avoid as much as we can. Certain types of terminals, now superseded products, do present a spearing risk. So I'm talking about breakaway cable terminals, melts, and the like that are used around the country, and is still one of the most commonly seen products on the network. So it is preferable to upgrade those to currently accepted products wherever possible. These terminals, so they present a spearing risk when struck end on. They also do not have any capability to redirect an errant vehicle if the terminal is struck. The barrier only becomes redirective beyond the terminal, unlike the newer products, which are redirective for most of their length. Another near miss that recently happened up near Wood End, I think. Fortunately, the barrier didn't spear into the vehicle, but it quite easily could have, and we do see that happen on occasion. This product is not a product that is accepted for use. I'll call it a fishtail end terminal, for want of a better term. I'm not exactly sure what that barrier is doing. It's certainly not shielding the pole up there. I suspect it is more of a pedestrian fence than anything. But a roadside risk has been introduced through the introduction of that barrier. With the rollout of continuous barriers across the network, there have been a lot of learnings. And through that, one of the great benefits of installing continuous barriers is the reduction in the footprint of the road that we can achieve. But there has been a lot of pressure to really minimise the cross sections that we are putting in. And we're ending up with a lot of narrow flush medians like this one that are only about 1.4 metres wide. And when you put in a barrier terminal that's about 800 mil wide, as this one is, there's not much room for error. This one was struck very shortly after being installed by the Coles truck. It was located on a road that was being progressively upgraded with barriers. And at the time it was struck, this happened to be the first median barrier that you would have encountered on that road. So it really would have jumped out at you and came as a surprise to an approaching motorist. And there have been a number of situations where median barrier terminals have been struck. Heavy vehicles are overrepresented in these strikes, just due to the sort of additional pavement width that they take up and their propensity to sway. And there's a high-profile example of a truck striking a barrier east of Melbourne, where the truck burst into flames. Again, a guard fence barrier with a wide median terminal located in a narrow flush median. So, look, we really do need to be mindful of our choice of cross-section, our choice of barrier system, and designing our barriers and terminal locations in ways that minimises the likelihood of them being struck. So the VicRoads supplement, which you can see there, provides a lot of great guidance. You really do need to read that in conjunction with the Austroads guide. As I mentioned, certain parts of the Austroads guide were updated in the recent update. There's a lot of other stuff in there that probably needs to be updated, and the VicRoads supplement captures a lot of contemporary thinking around some of those things. And in Victoria, and increasingly in other states, the adoption of continuous safety barrier is recognised as the first option on high-speed roads, and particularly high-speed, high-volume roads. There's been a rollout of continuous barriers on divided highways and freeways in particular, and now that's filtering down to some lower class two-lane roads. And that's it from me, unless there are any questions.
Yes, thanks, Jamie. Just a couple of things from me. I see we've got Evan in there. I'll get you in as a speaker shortly, Evan. But a couple of things I want to cover. Just one, I know there's people in this group who are super passionate about different particular topics. We've got some people really passionate about maintenance and wanting to talk in depth about that, environmental as well. People want to really get into that. I remind you that we're trying to cover across the whole spectrum of road safety barriers, and this is the fundamentals. In fact, in day 2 and 3, we have a dedicated multiple sessions on environmental stuff and on maintenance and installation stuff. And we just do not have the time in these sessions to go into a lot of depth in each of those. So I apologise for that in advance, and we're just trying to get across the board content through. But there are a couple of questions that have come in. One around curb profile and barrier choice and location. I believe you're going to cover that in the design section. Is that right, Jamie?
Yeah, I'm just having a glance at some of the questions myself. Some of those certainly we'll answer on Friday when we give a bit of an introduction to some of those key design considerations. So I'm happy to answer some general stuff now, but there will be more of that coming on Friday as well. Yeah,
no, good. And we'll do that. And there's a bit on, selection of barrier cost, choice of treatment in some later design decision ones. A little comment on the barrier end terminal behind you over your shoulder there, Jamie. You wouldn't be seeing that on the Victorian road, I hope. Now, I'm about to show you, oh wow, there's a few bigger, longer questions have come in there. I'll let you read those, Jamie. We've got a couple of minutes here. I'm going to show you through Moodle and what we want you to do in your break, but I'll give the opportunity, if somebody really wanted to elaborate on something and talk to it, just pop your hand up and I will give you the ability now, just because we have an extra 3 or 4 minutes that we can utilize for that. So pop your hand up if you wanted to make a verbal comment. Otherwise, we'll go through some more written comments, just controlling the time here as well. Jamie, do you want to address one of those written ones while we wait and see if anybody wants to pop their hand up?
Karen has asked about records of serious and fatal crashes caused by vehicles striking just barriers. Certainly that does happen, and I've no doubt there's a bunch of research available around that. I'm not sure if you can comment on that, Ken. Look, each jurisdiction, I'm sure, has records of those things. We've done work in Victoria and New South Wales where that has been a driving consideration. We've investigated fatal crash sites where barriers have been involved. It's a difficult thing to say. That it's often difficult to determine whether the barriers contributed to the severity of the crash. It's particularly though where terminals don't perform as they should, or as the currently accepted products would, that we see those situations.
Yeah, I mean, there's certainly been crash reduction studies around different barrier types, and I mean, that's how we generate our crash reduction factors. And we know that for different barrier types, we give less crash reduction factors. So used to be around the 45 for the old W-beam system, so a G4 or a style system, and yet up to sort of 90 for a wire rope system. And yeah, but on a case-by-case basis, we just want to ensure that they're installed as per manufacturer guidelines and different specifications. And Evan's going to talk to you a little bit about how they're tested and what you can expect them to perform like in the next session. So that was a good one. There was a question, sort of in-depth one, around the choice of barrier systems on the Melba and the Hume, and how do you choose which barrier type where based on which factors. And it's very complex. There's a lot of factors to consider when you're doing that. Part of the reason in day 2, when you're actually in there on site, we get you to do one, because you've got to weigh up all of this stuff. Jamie takes you through a bit of a process in module 3 of this one, just to sort of briefly run you through some of that decision making, because it's certainly not something we can just answer in, oh, well, you choose it based on this. There's quite a lot of factors to take in. Any other comments on that?
Yeah, look, that is something we'll talk about on Friday. It's a balancing act between providing a system that is sort of forgiving for the majority of road users that you would expect to strike it. You know, an alternative, as Tim mentions, might be to go with a stiffer system like concrete, but we know that they're less forgiving on the occupants of passenger vehicles, and we typically reserve those high containment level barriers for locations of particular risk. So look, that is something we'll spend some more time on Friday.
Yeah, and Evan's just chimed in that he'll elaborate a bit on that in his next sessions. And Evan, just priming you up, there was a question around what's the NRRAT score for Victoria and who's making those decisions and the like. So you can address that one when we get started, which is still not for about 15 minutes. So anybody got any questions before we I jump in and show you what we're going to ask you to do during the break here? No? Okay, that's good. So I'm just going to share my screen here, and I'm going to show you, hopefully. Right, Jamie, can you see Moodle?
Yes, Ken.
Good. Okay, so hopefully you've got access to Moodle. Everybody's got access to Moodle by now. If you don't, you shoot an email through to myself or back to Emma, who sent you an email, and we'll be able to send you a link to that. If you don't end up getting there, it's not the end of the world for now. You can do this later, but if we're trying to get you to do this during our little break. So what you've got here is you've got lots of things like the link to the webinar, all your instructions and those sort of things. You've got some resources here, so lots of different documents. You've got some course information like the agenda and the like. And then we have each of the sessions. So you've got then the slides that Jamie presented here as PDFs, but you've got this quiz, and we want you to undertake this quiz, hopefully in the next 15 minutes if you can. It's just 12 or 11 questions from the content that Jamie and I presented. It shouldn't be too hard, so hopefully in the next 17 minutes you'll be able to get onto that. Then we've got Evan's session coming up, and there are the PDFs of Evan's slides, and there's a quiz for Evan's and a little assignment, and it's going to be fairly quick assignment, and I'm going to take you through it at the end of Evan's session. But each of you, just in our last minute I've got here, each of you have been given a product, and there's a PDF list in there, and you have to then fill out the Word document based on the product, and I'll sort of open it up here just to show you, based on the product that you've been provided. So you'll be able to see your name there, and you've got a specific product, and you have to find some information from some of the resources that Evan will point you at in his session coming up in 15 minutes. So that's Moodle. So jump in, do that quiz in the next 15 minutes. Have a stretch, fill your coffee up, and get yourself ready as Evan, and strap your seatbelt on, because Evan has a lot to cover and he will just be plowing ahead. Yeah, so most people have received the Moodle, so maybe check your junk mail there. Otherwise, we'll send you another link if you haven't. So you feel free to pop that into the chat and I'll dig it out. But I've got quite a few people received it successfully, have access, and should be able to get in there and do that quiz and find all the resources. Okay, we're going to take a 15-minute break back at 1:45, and I'll say chance to win a prize if you are back on time. Thank you. Let's take a break. Okay, welcome back. Hope you had a good break there, and I saw that quite a few of you had got into the quiz, been doing those, doing quite well, and so that's good. Now remember, you do have 3 attempts at the quiz, so I see a few of you have had a few challenges with some of the questions, and that's okay. You can have up to 3 attempts at that. And so if you really struggled on that, you can do a second submission. So you go through, and it looks like if you're having a little bit of challenges with the software for some reason, we can get in contact with you. But yeah, I'm available for some one-on-one coaching, and we can work through and talk about it, make sure you understand the question, and I can point you back at where it was covered in the content to just make sure you're up to speed. But thank you very much. Quick question. I said a prize if you're back on time, and well done for being back on time. I'm going to step out of road safety barriers and a bit of random trivia. What's the capital of Bulgaria? First one to put that into the into the chat. What is the capital of Bulgaria? Who was it? Damien first with Sofia. Well done. I know Paul came in quick one, but he put a question mark after it. So yeah, you can't get that tone in written. Sophia? And sort of a few others, but Damien on the board there. Great. Okay. Well, thanks, Jamie, for your presentations there. And as I mentioned at the start, we've got Evan Coulson here from Department of Transport and the Victorian representative on ASBAP, the Australian Safety Barrier Assessment Panel, which he'll probably mention during his presentation. Evan's got a fair bit to cover in this session, and then I've got to just give you a bit more info on the assignment you've got to do. So I won't speak too much more on that. There was something else I wanted to say. Evan's going to cover, quite a few different presentations. Please keep your questions coming in. I'll feed them to Evan at different points. But over to you, Evan.
No worries. Thank you, Ken. Hopefully you can hear me. I've just shared screen and I lost my slide that was showing all the comments. So unfortunately, I won't be able to see those, but that's all right. I'm sure you'll feed them over to me.
I will feed you comments and we can see your slides beautifully. We can Perfect. Hear you loud and clear. I can't see your cursor on the screen though, if you're going to.
What about up here
now?
Yep.
You can see it now. Beautiful. Thanks, Evan.
All righty, no worries. Thank you. Yeah, as Ken said, I'm from Department of Transport from our engineering department. So we look after, and my team looks after the road design standards, and part of those are the roadside design standards, and being safety barriers is a big topic on those. So I do have a lot, but in short, really what I want to get through over the next 2 hours is the performance, how we evaluate barriers, how we accept those barriers and what the process is. And then really the second half of being, what are the different types of barriers that we have, both permanent and temporary. And I think that kind of gives a nice logical flow. And, as part of this, we'll kind of talk around, the fact that, we can only test so much, we can only evaluate so much, but also some of the pros and cons of the different product types, which may, I guess, come back to the question that Tim posted a bit earlier. So first up, got a video of how do we crash test? And the idea of, okay, well, we need to understand how these barriers work and how they perform, goes back quite a long way. And the idea is that really the most accurate way to understand how that performance is to run a vehicle into it. We can go with the theory and say, let's build a giant concrete wall as high as we need to. And in theory, that will stop the vehicle. But what we want to understand is how, that behavior, how does the occupant, behave during that impact? What's the damage on the barrier? What's the exit trajectory? And so really the most accurate way when we get into, how all that dynamically works together during an impact, the best way is to do some crash testing. Now, over the years, there have been standards that articulate how to crash test, ranging all the way back to 1962. And really, I think in Australia, we started to pick up around this time. NCHRP 350 is a word that some of you may have heard. And that implies, products that have been crash tested to this standard. And as we've moved on, 2009, we introduced MASH, a manual for assessing safety hardware, and there was another update to that document in 2016. But really what these are crash test protocols. Here is how we want you to test your product, your barrier, to understand how it works. And so we have moved for permanent products to MASH, and we are very close to moving temporary products over to MASH. Now, those are protocols, so they don't necessarily stand by themselves. It's actually Australian Standard 3845 that brings all those together. And that is our Australian standard that says, a product needs to meet these requirements to be deemed suitable. And in that, it mentions it needs to be crash tested to an accepted protocol. And it highlights these three protocols, and that is the old 350, the current MASH, And it also references a European standard called EN 1317. And the idea is that we recognize these protocols so that we can get products from all over the world. If we want the best products, then we want people and suppliers to bring them here. So we acknowledge all three. However, to provide that consistency, we use MASH as the baseline. So even if you crash test to one of these other standards, you need to be proving how it works to this standard and trying to justify any differences that you might have done during testing. So Australian standard, mentions MASH as the basis, must be crash tested, can be crash tested those other protocols. And it also kind of mentions that, acceptance in another country doesn't necessarily automatically make it approved here. There is the AASHTO, or the group in the US, FHWA, that approve products. They have a slightly different process to us. Yes, the crash testing might be the same, but we, I think, arguably go that little bit step beyond and try to really drill into how is this actually going to work, in practice. And it's not just a tick, yes, you passed, therefore you get acceptance. Why do we crash test? I mean, the short answer is really to understand how they work, but also to provide a bar, something that suppliers aim for. If we can achieve this performance, then it will be accepted. And the idea there is that everyone, all the suppliers, are aiming for the same level of performance, and therefore we have some level of consistency when we can compare products. And yes, we see different types of products, achieving and standing out in some areas than others. But ultimately, they're all aiming for the same, criteria in which we evaluate, which allows us to compare. So how do we crash test? Well, really, I mean, if we look back at those videos before, at the crux of it, we've really got, we need to pick a vehicle, we need to pick a speed, and we need to pick an angle. And this, I guess, depends primarily on what are the types of runoff road scenarios. What we can't do is just pick the worst case. We can't just find the largest vehicle, the largest angle, 90 degrees, and the highest speed and say, let's design for that. Because what happens then is we now, have very limited options. Someone is designing for the absolute worst case. We're paying for that. And we're probably not going to have an overall good outcome for the network. And so what we really need to do is find that balance. And often in engineering, it's that 85th percentile. It's actually, in theory, a little bit higher than that in this case. But it's, what is a reasonable set of vehicles, a reasonable angle and a reasonable speed to cover, the majority of the network and the majority of impact scenarios. And this, kind of comes into that question that Karen highlighted there before, in that not every barrier is perfect. Even if you installed a giant concrete wall and said no vehicle could get through that, it still has risk to the occupants. But also in how we test, there are potentially, it's low, potentially scenarios where it exceeds either that impact scenario, whether the angle is higher, and the speed at the same time. So it is possible, but the idea is that the crash test represents a fairly conservative, and I think they call it the worst practical case in the standard. Now, with the vehicle types, first up, choose a vehicle. Now, the distribution of registered vehicles within Victoria looks something like this. So we have the majority of vehicles are passenger vehicles, and we're talking around, we have 1.4 million vehicles in this around 1,600 kilogram range, coming down towards more that, 1 kilogram, or the 1 ton, sorry, and then kind of past. And then, yes, we do have large trucks, but they are fewer in numbers. And so in the crash test standard, they've picked several vehicles to try and represent this. They've picked a small car, which fits down here in the 1,100 kg. They've picked a large pickup trucks, which is representing a large passenger vehicle. So in theory, with these two vehicles, the idea is that we've covered a small and a large passenger vehicle type. The optional are then 10 tons, 36 tons, and there's even a tanker, which is the same weight, but a different makeup, which we're talking is 10 ton and 36 ton is off the charts. It's big and it's meant to represent that very large vehicle. The small car representing, the most risk to the occupants, the potential to go under the barrier. The idea of the small car is really around that underride and also the occupant severity. And, if we pick a barrier type to kind of see the difference, we're choosing wire rope, which has been tested for both the small, the large pickup and the truck. The cables are going to interact with it. And that is part of the idea of spreading out the cables or the rail, is to try and make sure that it does work for all three. The next one, the pickup truck, is supposed to represent that high energy impact. Yes, it's slightly high, and the change here from NCHRP to MASH, the bumper is taller, the weight is bigger. The idea was, okay, vehicles are getting larger, we should increase. And this represents, that big impact likely to penetrate the barrier, impact. And again, similar with a wire rope, which I think, or maybe this is a guard fence video, we can see, the choice of height is going to depend because you need to get the small car and the pickup. But we can see that the barrier there is at the right height to try and engage that bumper of the vehicle. Finally, the larger vehicles. So we've got the 10-ton truck. Used to be 8 ton, now up to 10 ton with MASH, and also a larger impact angle. So a lot more energy in this, a very big jump up, all the way up to our TL5 and 6, our 36 ton trucks and our 36 ton tankers. The difference, while the weight is the same, it's the behavior in the tanker. And its movable liquid actually creates multiple impacts almost during the redirection process. As the front impacts, the tail swings in, then you have that secondary rotation of the vehicle from the load, which means that it is a bigger test, even though the size is the same, or even though the weight is the same. And a video here of a TL4 vehicle. Now, again, that barrier has to be able to stop all three scenarios. So, the higher the TL4, you generally got a greater spread of cables. There used to be a wire rope barrier that I don't think, there was like one installation maybe 20 years ago, where all the cables were grouped together. And the idea was to try and get the best performance as possible for the one vehicle type. But once you add in all three, and your goal is to then, be able to redirect and get good performance values from all three, you start to look at the barriers slightly differently, and your design of the barriers changes for that. So we have our 5 or 6 test levels, and really it's just different combinations of that vehicle, that speed, and that angle. Now, in this case, we've got our vehicle types here. We pick an angle, and this is based off the runoff road scenarios that we see. 25 degrees for both the passenger vehicles and 15 degrees for both the larger vehicles. And basically, we combine those together. To achieve TL1, you have to test both passenger vehicles at 50. Same again, 70 and 100 for TL3. And this is probably the minimum, the default most suppliers are going for. This will be the most common barrier type, and that is both passenger vehicles at 100 k's an hour. And we can see the impact energy going up, which is just a half MV squared. TL4, moving up again, you do the same crash test. So you can't just raise the barrier to try and focus on the 10 ton. You still need to make sure that it works for the passenger vehicles. but you add on the test for the 10 ton, which is now 90 kilometers per hour at 15 degrees. Now, that doesn't mean that the barrier only works at 90, because we're still testing to 100. It's, the representation that the protocol has identified that a worst practical case is the 10-ton truck at 15 degrees at 90. You don't just pick the worst possible scenario, and we are guided by the protocol. But they're saying this impact is, that reasonable step above. And finally, for TL5 and 6, which look the same except for the vehicle type, 100 Ks again for the passenger vehicles plus your 36-ton truck at 15 degrees and at 80 kilometers per hour. So again, it doesn't all of a sudden limit the barrier to 80 Ks an hour. That is just the impact test, which, I guess is a good point to just pause on for a minute. And it is very good to know, how these work and how we've tested, because, the progression of barrier development is really dictated by the protocol. We set, or the protocol gives a set of criteria or a set of crash test objectives, and the suppliers, proprietary companies, invest in how they're going to design that barrier so that they can pass that test. With the introduction of MASH, it was a new set of crash tests. Now, that doesn't mean that you just can all of a sudden go and retest those on the old barriers. We had to give the option of where there's a new set of criteria. It may mean that the barriers look different, and it has, and therefore you can aim for that. And I guess, there's always the question of what about adding new tests? And, the best way or the most reasonable way is to, make sure that that test becomes the new protocol so that suppliers can redesign. And the idea is, we are giving that balance. We're not trying to, push them and say, oh, well, what about a Pajero at this angle and speed where they haven't necessarily designed for that, if it's outside. So it is tough to kind of say, okay, they've tested and they've designed a barrier to stop these. Therefore, what about these other scenarios? I think over time we learn more and more through infield, and there's now simulation, which has been really valuable to understand that big matrix. But just doing this, just trying to develop a product that passes MASH TL3, we're talking in the realm of millions of dollars in the development, the testing, the bringing it to market, the getting acceptance. So it is, a big investment.
And that was one of the questions that's come in, Evan, around, couldn't we just use modeling? There's pretty advanced modeling out there and simulation to do this rather than a physical test.
Yep, I might come back to it. Good question. And I'll finish all the performance, and then probably I can summarize how modeling kind of fills in that gap.
Yep. And the other one was just a higher level question around, you've sort of immediately shown that with 85th percentile and the like, and the question comes around our aspirations of zero death and serious injury, and we're making these compromises already. Any comment on that?
I think that there's no trying to hide around this. The aspiration of zero is an aspiration that, and it's a really great aspiration. And the idea of the Swiss cheese model being that you have more than one treatment to mitigate risk. So, we're not just relying on one thing. We're relying on the system to achieve zero. Now, again, if we set the worst possible case scenario, we'd be decades behind ever putting barrier on the roads that we have, because every barrier would cost, 10 times as much. And, that difference, it costs so much to achieve 85%, costs so much more to achieve that extra 5% and the extra 5%. And so it is a bit of a balance getting there. So, we should be pushing barriers to be more effective and to contain more vehicles. Yes, definitely. But I don't think we should kid ourselves that this is the only solution and this is going to be 100% effective all the time. But also, I don't think we need that to have the aspiration of, zero.
Good. And last one was around are any car manufacturers designing cars to suit barriers, or is it always the other way around?
Really great question. At ASBAP, the Off-Road Safety Barrier Assessment Panel, we have talked about this, and there have been a couple of conversations in the last 12 months around that interaction. And I think, the short answer is no, but there is a level of awareness. And the idea is really just to raise and increase that awareness between the car manufacturers. And one of the topics was actually around bull bars. And we have, suppliers and manufacturers saying, here's a bull bar, it looks cool, or you might actually be using it for a practical purpose of hitting your cattle, protecting your car, but also it does change the performance. So there has been more of a collaborative discussion in recent time, but yes, I think that is a really great systems thinking question. If we are to achieve zero, then we should be exactly merging those two. So I think it's not solved. There's a lot of opportunity in that space. And that's kind of the open question to everyone is, any ideas like that, the better we can get. But yeah, not super, interacting at the moment.
Yeah, no, good one. And I suppose one more that's coming from Debbie around the advanced safety features within vehicles, airbags, and different bits and pieces. Are they being accounted for in these test protocols?
These are worst practical cases, and the protocols actually, stem from Europe and America, and they are finding that no one wears seatbelts. So the crash test actually assumes no seatbelt or any of those safety features. So it as that percentage increases and that confidence that people are wearing seatbelts and all cars have this sort of safety features, that might eventually come into the protocol. But for right now, as of MASH, the worst practical case doesn't assume those things, which is actually fairly conservative for us in Australia, where I think we can almost assume those things.
Good, thank you.
No worries, thank you, Ken. And I'll keep the simulation one in the back of my mind, and I'll get to it in the end. So this is just a good little diagram that shows that energy, TL1 all the way to 6, the energy does increase. A couple of highlights here is that 350, the old protocol, used to have the same energy, but obviously center of gravity and other things were involved. In the new MASH, it's a big jump. TL3 and TL4 products will look different, and it is a big significant jump, which is fine. That's great. And there is a lot more products coming into the TL4 market, but really just wanted to highlight that difference. If you're comparing 350 and MASH products, TL4 and TL4, that's a big jump. In the TL5 space, again, there's no difference in the energies, but we know the vehicle type is what makes that difference during the crash testing. For terminals, it's a whole nother matrix. But in theory, vehicle type, angle, speed. The vehicle types are all passenger vehicles in the terminals. Angles and speeds really depend on that type of terminal. And there is a quick video here, which I think is loud, and we'll get into some better videos in the terminals. But the idea is it's the same pickup truck running in at a speed. This is directly in the middle. There is also an offset test. And really, it's the same sort of measures in all of them, survivability, and I'll get into a bit of that in a minute. Sorry, let's get to the next slide. Crash cushions, similar again. There is one additional test for crash cushions, and that is just sort of because of its behavior. So speed, angle, and vehicle type. Okay, we know how to test them. What are we looking for? And there's really three main things. Does the barrier hold up? Is it structurally adequate? Does it redirect the vehicle? The next, do the occupants survive? Is the risk of survival high? Obviously lots of different things can happen and lots of different factors are involved, but basically we get a threshold. And the idea is that the vehicle needs to have thresholds lower than the limit, because that increases the chance, decreases the chance of injury or fatality. So there are some decelerations. There's also some dynamic elements of that occupant risk. And finally, the post-impact response. Yes, we know the angle and speed that they're coming in, but we also want a certain angle when it departs the barrier. We don't want that bouncing effect. Obviously, that will depend on the rigidity of the barrier and everything, but it is a criteria in there. And there have been some products in the past that did fail this and never made it into Australia for this. So in the structural adequacy, we're looking for things like that additional capacity, in the rail space, tearing, in the concrete space, cracking and spalling. We don't want products to be on the very limit of failure. And so we're really looking for that structural adequacy. Now, it doesn't need to be able to withstand a secondary impact. The idea is always that we would come out and repair it. However, it does have a factor of, if it can, then better. And, it kind of depends on the different systems about that secondary. The next, occupant risk. So yes, there's the ride down values and everything, but there's also debris and damage to the compartment, to the cabin. So there can't be more than, a certain amount of deformation around that cabin. There can't be anything that penetrates into the cabin. And additionally, you can't have that certain roll and yaw of the vehicle, as well as what I mentioned before about those ride down values. So the G-forces exposed or placed on the occupant. Which is one thing I kind of want to touch on in this, is that we have these thresholds of maximum preferred, and they give this that obviously the lower the better. But if you achieve this maximum limit, we're still in a low likelihood of injury. And I often hear this: concrete barriers are unsafe and wire rope are safe. And I really wanted to just highlight that we're well under these limits for all three. Yes, wire rope, flexible barriers are more forgiving. These ride down values are less, which is great. And it means that the likelihood of an injury is lower on these barrier systems. But again, we're still under the threshold, and we're actually still under the preferred threshold for typical F-shaped concrete barriers. So it is important to note that these are different. And obviously, if we want to reduce that risk, lower severity is great. But, if you've come to this training, I don't want you going off saying concrete barriers are unsafe. I think it's about their impact severity is higher. However, there are a whole lot of other pros and cons of concrete barriers versus wire rope, in constrained locations. Impact trajectory, again, needs to exit a certain box from where it left the barrier. If it exceeds or it exits through the B dimension here, then it would be a fail. And we can see, I might just play one of these because I'm taking a little bit slow, but I need to probably push on a little bit. Well, that's not a great video. Let's try the other because we can't see. But the idea here is that you will be able to see that when the vehicle does exit the barrier, they've got cameras above, they've got cameras on all sides here, and they will draw that virtual exit box based on the point that it departs right there. And we can see here that it would be exiting that A dimension. So conditions of use. Now, I'll get into this in a second, but when we're looking at all of those evaluation, those crash tests, yes, there is the pass fail, it worked or it didn't work, but also there's a whole lot of factors associated to that pass. And that information is put into a conditions of use document. Now, and we'll get into that a little bit more, but the idea there is that to pass MASH TL3 or MASH TL4, you have to do a whole bunch of different tests. It's not just the one test. And throughout that, it will depend, your length of barrier will depend, will have a factor or have an influence on that pass. The amount of room behind the barrier will have an influence on that pass. The way that you anchor it to the ground, the distance to hazards and everything. And so all that information is published in one of these conditions of use. And it basically, highlights that, yes, it has passed that test level. And here's the conditions, the parameters that you need and that we use during the crash testing to achieve that. It passed MASH TL3 with a 2 meter post spacing. It needs this much room behind the barrier to be considered MASH TL3. And so these conditions of use, and I'll get into them again, kind of articulate how far we can stretch those barriers and still be confident that it achieves that MASH TL3. Similarly with the foundations, depending on how the barrier is anchored to the ground, driven posts generally work in all, but we're talking about temporary where you have to pin into some sort of solid surface. These foundation conditions can get a little bit more complex. Which brings me to, I guess, simulation. And the next slide is the end of this one. But simulation is growing and growing, which is fantastic. And there is a product called LS Dyna, which is a very complex program. We're talking about, you want to run one of those crash tests, you put it on Friday afternoon, you go off to the weekend, and it might be done Monday if you're lucky. It is simulating, every instantaneous and the effects on the next and the next. So it is a very dynamic program. It's, it's not strand 7 or a static model. It is a very dynamic model. And, what's most important is building your model. You've got a barrier, you've designed a barrier, but how all of those components interact together is quite complex. And so we actually use this term of, is it a validated model or not? If you just create a model and you run a vehicle into it, we're going to have no confidence that the parameters and the interaction between those components is accurate. And so what we require is it to be validated, which basically means running a crash test and then comparing notes almost, but validating and calibrating your model so that your simulation, is the same as your physical crash test. Once you have that model, it's all about those little changes that we are accepting as simulations. So in theory, you wouldn't get a product approved straight off the bat with simulation. However, once you have a product accepted, you've probably got 3 tests that you can calibrate with. And then you might say, okay, well, what happens with a 1 meter post spacing? Or what about if I leave a post out? Or what happens if I put it behind a curb? So it is important to make sure that that model is calibrated and validated so that there is that level of accuracy. But then, yes, we can accept simulation for those little extras. So I can happy to take any questions, Ken, while I jump over to the next one.
Yeah, we better jump over to the next one. There are no questions have come in at this stage that we haven't covered off. So let's keep pushing on. I might jump in with a quiz a little bit later on if we've got time.
Sounds good. This will be a quick one, and then we can get into the products. So we know how they've been evaluated, and now it's the acceptance process. And basically, in short, the suppliers want their idea, their product to go onto a list, which somewhat acts as a bit of an advertising page, but it is also the list of products that have been evaluated and assessed. Now, it goes through a bit of a process. The supplier has the idea, they know the protocol, they do some development, a whole lot of investment, crash testing, and then we get into basically the 2 roles, ASBAP, Off-Road Safety Barrier Assessment Panel, and then the road authority itself. Now, ASBAP is basically a group of representatives from each state road authority. So in the past, we were all doing different assessments. We're all doing our own assessments. The idea was, let's all get together, assess these products. It means that we're going to accept them in the same way. So we're going to have some national harmonization. But it also is a much more diligent process because we have multiple people from different perspectives looking at the products and doing that evaluation. So ASBAP, the Off-Road Safety Barrier Assessment Panel, does that on behalf of us. They look at the crash tests, they look at the product manuals, they look at the risk criteria and everything to deem whether the product is acceptable or whether the product passes and meets AS 3845. So ASBAP meets 4 times a year, and a lot of products go through there, especially a lot of variants at the moment. So, a lot of the products are set in MASH now, and there's different variants coming through and testing and modeling of that. The panel doesn't approve though. They're just recommending it. So the panel is saying, we've evaluated it against AS 3845, against MASH and against everything else. And yes, the product would be acceptable and is recommended for use in accordance with these conditions. So they do the hard bit, but they don't necessarily approve it for use. Now, the submission pack is quite detailed, and the suppliers are the ones filling this out, all about, how they've manufactured it, what are the components, the materials, the crash testing, the videos, and everything. So it is quite thorough. And ultimately, they get a bit of a letter that says, yeah, all right, your product has been assessed, it's recommended for acceptance, and here are the technical conditions of use that panel has recommended. Moving on from that, so the Off-Road assessment is done. The product is then submitted to the road authority by the supplier. So they've said, yes, my product has been reviewed. I have a TCU, a technical conditions of use. Now, will you allow that on your arterial roads or in your region? And from there, the road authority, so my team would grab those. We've had involvement through Off-Road, so we're probably pretty familiar with the product itself. Does it add value to our network? Does a product integrate with our local network? And this is where we start talking about, are there transitions and connections, etc. Is there anything slightly unique in Victoria versus other states? Do we need to add any additional requirements, that might be state specific? Now, the first goal is not to have these, when we're aiming for national harmonization, so it should be a last resort. But there may be times where we need to add a specific requirement. We'll go through an internal process of approval, and then basically they've got state acceptance. So a letter of acceptance will go back to the supplier and say, yes, thank you for your submission. Your product, has been accepted in accordance with these conditions. And most of the time, and I think almost in 90% of the times now, it's the Off-Road's TCU, and we will publish that onto the website. So they get their letter and they celebrate, and then it goes on to this list, Road Design Note 0604. This Road Design Note gets updated quite a bit for new products and for variants. But in theory, it's split up into a whole lot of different sections, permanent products, temporary products, and we also include some of the legacy ones that have phased out or used to be accepted at a certain point in time but are no longer. And in those, we basically provide a little bit of detail for each. So name, supplier, the level that they were accepted to, so whether it was TL2 and TL3 or just TL3. We now provide a link to the TCU if we've accepted that. So in the most cases, and I think, as I said, kind of 95% of cases, we will accept the product in accordance with the Off-Road's TCU. So there's no point adding any Victorian requirements. We've already done the evaluation. We accept it as is. That'll mean that this has a link and a date, and basically it'll say nil, though it looks funny there. In rare cases, there might be the need for some additional requirements, some state-specific requirements. And in that case, we might link them or reference them in there or provide a link over to the detail sheet. So just wanted to highlight that there will always be a TCU or a detail sheet. However, there's not always a detail sheet. So there's always one or the other, but there's no longer a detail sheet for every product. And that saved a huge amount of time for us. We were maintaining 64 of these documents. And once we compared any differences, we ended up getting it down to about 9 and just adopted the TCU directly, which has been really beneficial for us. All the other states have something similar, a list and a link to the TCU. So that's an RMS example there. But we're all very consistent now with the Ostrode scheme, which is great. So summary of this, don't use a product that's not on the list because no one has evaluated. No one's done that check. And that includes variants as well. Yes, some variants, don't change the performance heaps, but little things can make a big difference. So always try and stay within that accepted list. Always check the latest one. Again, don't modify or use the products differently because in theory, that's a variant. It could change the performance. And really, yes, there are constrained locations, but it is about trying to take a very pragmatic approach to those and acknowledging if I do change the product, it could affect the performance, and let's sort of understand that risk and move through that. So that is the end of that one. And I think happy to take a break, but it will be straight into permanent and then into temporary after this.
Yeah, okay. Well, maybe 1 minute just for people to have a quick stretch. And I'll just say that last little session, very important for the assignment that they're going to be doing at the end of this session, because they'll be going and finding a product, finding its status in Victoria, and then making some different comments that they find in the detail sheets and or technical conditions of use. So it was an important one. So let's just take another 45 seconds and we'll get back into it.
All right. Here, I can open this down here. Yep. Alrighty, I'll get into it. So we've got an hour left, and it'll be basically a whole lot of permanent products and then temporary products.
I was going to say, I think you've got an hour and 15 minutes left.
Oh, perfect. Great. Because I feel like I always go over on this. So that's a bonus. I'll pretend that I've got an hour, and no doubt I'll use the hour and 15. Though I'll give you some time back for the exercise.
Okay.
So basically, there are a lot of products. I don't think, we can go through every one in detail. But what I really want to do is talk about the different types, their general behaviors. And I think this is all kind of leading towards your question, Tim, earlier about how do we choose the different product types. And so hopefully I'll equip you with, what to look out for and how some of these work, which will help with that selection. And also, in constrained locations, okay, how do we, which way do we go? So we're going. Alrighty, so I've covered that. Normally, if there's a break, I need to go over this again, but TCUs will articulate the specific requirements for each of these, and that RDN can be found on the website. I might just quickly go through this, but basically, we've got the road design note, new format now, apologies, and we've got the products sorted into different categories. Now, that doesn't mean that they're actually crash tested all the same, but it's generally around that behavior, that style, whether it is a steel barrier system or a wire rope or a certain terminal type. We have grouped them for a little bit more, clarity and also comparison. In addition, we've got a section on motorcycle products and truck mounted attenuators. And then we've also got the legacy stuff. So permanent stuff. First up, just wanted to highlight the difference between proprietary products and public domain products. Now, proprietary basically means that a supplier owns the intellectual property for that device. So they've done the development, they've done the investment, they've got it approved, and therefore the product needs to be purchased from them or their supplier. Public domain is when the road authority provides the details of a product. And we used to do that, the old Type B or the G4. That is an example of a public domain system. And the way that that was developed was testing in America, by a public group, by a road authority. They gave us the details, we've used it. But the reality is that, as a road authority, as a public entity, is very hard to keep up with the developments and the testing and the regular changes. And so there are far less public domain systems these days, and most of the products are proprietary. So longitudinal barrier, main goal, contain, redirect those vehicles. So what do we have? So wire rope, first one. And general components, yes, all the components are slightly different, but generally we have post foundations, concrete. Size is slightly different, but it's generally a cylindrical post foundation. In that we have a post sleeve. So something that goes into the concrete that allows us to take out damaged posts and insert new ones without having to touch anything below ground. We then have the post itself. The shape is slightly different based on that supplier's design. Where the cables go is slightly different, steel plates, etc. But in theory, they all have a post. Got the cables, 4 rope, and then at some point we need to get down and anchor that to a foundation. Now the foundations again and how they connect are slightly dependent on the product type, as well as this sort of transition, this terminal piece. But in theory, we have to get from the desired height down to the ground at some point to anchor it, and they all do that slightly differently. Now, how does it generally work? Is that the posts hold up the cables, and when the vehicle impacts, the posts hold the cables there for long enough for those cables to engage with the vehicle and redirect. The posts play a pretty big part in that redirection because they need to be strong enough to make sure the cable engages and pulls into the vehicle. They need to make sure that the cables don't separate and go over and under the vehicle. And obviously, they provide that upstream, downstream resistance. So the less posts you have, or the weaker the post is, the more deflection you're going to get. And so if I can break any perception right here and now that, the posts only hold up the cables, you could make them as weak as possible. Get rid of that misconception because it is definitely not true. They play a big part. And if we didn't have them, or we had something very different, the cables would be separating. They might be going over and under. They might not engage with the vehicle as they do. So in theory, the posts are important and they're utilizing that upstream, downstream resistance. 3 main suppliers of wire rope here, but in general, we're talking about some slightly different designs, but they all have a post of some sort and 4 cables. Some recent developments in sort of some of the suppliers in, okay, can we make it faster to install? Can we integrate the post cap with the spacers? That's part of the new MASH developments, is trying to make it faster to install. But in theory, they've all got they're generally the same. Pros and cons really of wire rope is, one, on the benefit side, it is the most forgiving. So the lowest occupant risk values, we have that deflection, less likely for someone to sustain an injury or to bounce around within the vehicle during an impact. They can contain larger vehicles. So the products are MASH TL4. And really, we have seen larger containments. Yes, the barrier might deflect more, with a very large vehicle, but the cables themselves are very far from, they have a lot more extra capacity before they'd snap, if ever. And so really they do have that extra containment for higher vehicles and for trucks, which is a pro. Low installation cost, generally on a long length. Low repair cost generally, if we've got a good offset, because it is just about replacing the posts. We don't have to do anything underground. We don't have to do anything to the cables. It's really just some new posts and obviously the narrow system width. In the limitations though, large deflection area. Perform great, work well for trucks, keep them quite stable during an impact, but you're going to need a bit of room behind it. Long lengths and curves actually have a bit of a factor on the deflection, which is something, another complexity to consider. From the installation perspective, they don't work very well on tight curves because the cables are tensioned. They want to pull over the posts, on a cold day, as well as, you need a decent length of the barrier. So, in theory there, we're kind of locking it out in some locations, easily damaged. So we really don't want it right next to the road where it could be knocked all the time because it's going to mean a whole lot more maintenance. And it's not compatible with some products called the rub rails, motorcycle rub rails, which have been crash tested. So pros and cons of them. But, really, if you've got a fairly unconstrained site, and we're talking our highways, good room, these are generally going to pop out as the preferred system. It's where we start to get into these other sections where we don't have the space, we've got tight curves, we might have to place it a bit close to the road, and we don't want to kind of always be out there repairing it. The next product type is the flexible guard fence. Now, this kind of performs similar to a wire rope in theory. We have a rail, a continuous rail, which is kind of like just, wire ropes, a rail of some sort attached to a post. And the post, is considered weak in the fact that when a vehicle hits it directly, it will bend at ground surface. The W-beam releases and shifts kind of with the vehicle. And therefore, you're getting a bit of deflection. The post is getting out of the way, though it holds the barrier or the rail there up and downstream. So it kind of performs similar to wire rope. However, the fact that it is a consistent rail does get rid of, it does have some different pros and cons. Now in this space, we've got sort of 3 W-beam. So it's just 1 lump and 2. They're all in the TL3 space. But generally there's 3 systems. The post is slightly different. The rails are exactly the same. How they release, again, is the subtle difference as well. To get MASH TL4, you will need a larger rail, and this is called a thri-beam. It is taller, there's more steel, and that provides that extra capacity for that big vehicle, that higher energy. At some point, the rail, if you just kept increasing the impact energy, it would tear. Which is why, for the higher containment levels, we go with a thri-beam. There are some systems in Europe, which is again TL5, and it's a thri-beam plus a W-beam on top. It's a lot of steel, but you would need that to get that really high capacity. So watch a quick video of this. But I guess what you're kind of looking for here is, the posts that were directly impacted do get out of the way of the vehicle. And now we've got the sort of upstream, downstream posts providing that resistance. So the rail has left, it's now engaged with the vehicle, and hopefully it stays, engaged with the vehicle the whole redirection process. Oops, wrong click. And then we can see there that it's redirected. Now, from here, we can see, okay, posts are damaged and rail is damaged, but, a certain distance up and down, we will have the barrier that isn't damaged at all. And I think this is just a different view, so I might skip. Excuse me. Here's a good example of a W-beam and a flexible barrier where you might not be able to use a wire rope. There is less distance to the traffic lane, but also to the hazard, tight curves, etc. So pros and cons, still very forgiving. We still got very good deceleration rates, risk, occupant risk values, no deflection factors. So, length and curvature isn't going to change the deflection. Can be used on tight curves. Damage is localized. Connections to other barriers are quite customizable. The big one really, though, is that it's still a bit of deflection. It's not zero, which is when you really need a rigid concrete. And also, I guess when we're talking about containment level, W-beam only fits within the TL3. You will need that extra Thri-beam to get to TL4, which means if we're kind of comparing, to wire rope, we probably need to be going the Thri-beam comparison. W-beam doesn't quite get as much, even though it has these other benefits, which are very useful when you've got that sort of constraints. The level above this is where we start to get into semi-rigid, and we're also talking about higher containment levels. Semi-rigid generally, is defined by its stronger post. So the post is not just getting out of the way during an impact, it is trying to remain fairly rigid. Obviously, there's going to be some deformation, so it's not called rigid. There will be some movement, but the idea is that each post, is resisting that impact from the vehicle. Here we've got some W-beams within the semi-rigid, some Thri-beams, and also a roller barrier, which in theory, it's got the posts, it's connected by a rail, during the impact, that rail and that steel will provide that redirection. Pros and cons for semi-rigid is really lower deflection. If you haven't got the room, then, this can fit in. It might be less forgiving because it is a slightly harder impact, but it's still within acceptable ranges. And, if you don't have the room, then it's kind of, well, you don't have the room. So, you need something in there to protect those hazards or protect whatever's behind it. Higher containment, whole of life may be greater. And I guess the one limitation is obviously greater installation cost. These will cost more than a wire rope or a W-beam. But if we're in the right scenario, if we've got really high volumes of vehicles, we've got really, close offsets, it's hard to get into, whole of life may actually outweigh it. And, we are seeing sort of in a lot of the urban scenarios where we may have had wire rope, we're upgrading, we're bringing in a lot more volume of vehicles, it's harder to get into, we're using our managed motorway systems. A system like concrete, where it really is kind of durable to those nuisance impacts, is going to kind of come up as a better whole of life. In rural, though, where we can get to it, where we have that room, we're not going to quite have that whole of life. It's whole of life is going to trend towards those more flexible systems, but definitely in those urban constrained locations. And that's a natural progression, for all cities across the world. We have a road, we've got the room. As we get more built up, we get less room, more vehicles, more lanes, and naturally some flexible barriers are changed over to concrete during the upgrades because that whole of life is slowly changing as volume changes. Common variants and modifications to these, and again, we're talking about accepted variants. Post spacings. Some products have accepted post spacing, so normally 2 meters. Sometimes you can use them as 1 meter. Again, a lot of these have only been modeled or simulated. So while the working width, is not perfect, and we're not, when we talk about working width, it really isn't a down to the millimeter or the point millimeter that we publish. And so post spacings, again, they do reduce the working width, they do reduce the deflection, which is really great in constrained locations. But again, we don't really have a super accurate knowledge of the working width because some of them have been modeled rather than physically crash tested. But no doubt these are very useful variants and they do work. Base plates. So the idea, here I've got one. If you don't have that depth, you've got a culvert, you've got a service, you can't drive the post. They have done some testing and modeling with this. And in theory, it is meant to perform exactly the same, and it does. The post bends at the ground level. It just happens to be attached to a deck. So again, slightly more expensive when you talk about, the foundation and the concrete costs, but, a very good alternative. Post omission. So the idea of leaving out one or two posts. Again, they've done some modeling on these, and the idea is that they've modeled impacting it right here and in the middle, and it does work. And it's really great to get over a service if that product has been approved like that. Very different to, just approving a 6 meter post spacing. Really they've just modeled that performance, for one sort of, or, for two post emissions. So I wouldn't be doing this regularly along the barrier. But, really great for that odd service here and there. Some other sorts of modifications we've got are some retrofit modifications. Over the years, W-beam has been getting higher as vehicles get bigger. We have an Abraham block, which is a really great way to upgrade an existing barrier. Obviously, we installed this barrier at a certain point in time. Yes, standards have changed, but that barrier was installed with an idea that it would provide value for 20, 25 years. And these attachments are really great ways to try and say, okay, well, let's get some extra capacity out of the system while we're here and increase the height. Similar with EasyGuard, they've got a kind of similar scenario. In this case, this isn't, kind of the main reason isn't to increase capacity, but more asphalt overlays or subtle changes to the pavement height means we can increase that pavement. So that is longitudinal barriers. And I've lost my 11. Next up, terminals. And I didn't talk about concrete, but I think I've got a bit more rigid stuff later on. But terminals, the idea really of the terminal is to protect the end of the barrier. It's not part of the barrier, needing to redirect the vehicle. Some terminals do redirect if you hit them at a certain point. But the main focus is just to protect the end of the wire rope. Sorry, the wire rope is next, but of the barrier system. So with wire rope, it's fairly similar. You've got your full height and you somehow need to bring it down and anchor it. The best way to do that is gradually. And obviously this has gone through the same tests of, end on and at an angle. I guess the short answer with wire rope terminals is that they work, they've tested, they've passed. They don't necessarily absorb any energy like the next ones I'm going to show you. If someone impacts here at the angle, they will go through, and that's part of the gating section, which is a fine performance. In theory, we're only considering the barrier to be starting here because that's where we need the barrier to start. The terminal is just part of the barrier to be able to anchor it and protect the ends. But yeah, very similar. A couple of the posts might be slightly weaker at the beginning, which will depend on the specific product. Guard fence terminals, however, a little bit more complex, and there's basically one terminal for each of the different suppliers. We've got the MSKT, the Nash sequential kinking terminal, ETSS, and max tension. Now, these are all pretty much tested to 100. So they've got that Nash TL3. Part of them is redirective. So actually, even though that whole length is the terminal, if you impact the barrier sort of, I can't remember what the distance is, but maybe 4 meters from the end, then you will redirect. So that section of the terminal can be considered part of the barrier. And then we've obviously got sort of all the complexity and the anchoring of it over here. And I'll go into a bit of detail, but from here, you can actually see two different types. One here, you can see this anchoring type component at the bottom, and that is the ETSS and the max tension. And the other one, you haven't got that, called the MSKT, and that's because they both work in slightly different ways. And it's actually, there isn't really a better one than the other. They kind of have their different pros and cons, and they both pass the same crash testing and same performance criteria. So really, I just wanted to kind of highlight how they work and I guess the pros and cons of them. The MSKT, this one up here, sorry, the extruding head style. Basically, you've got your W-beam overlapping, which is the gray lines I've drawn, and you have a steel terminal head placed on the end of the first W-beam. Now, obviously, if you didn't have that and someone impacted head on, it'd spear through the vehicle and probably keep spearing. But in theory, what you're putting on is a bit of an end block. And when someone impacts that terminal, it extrudes, or the rail is pushed through, and it extrudes out the end. Now, this pushes it away from spearing, obviously, but as you push it through the terminal, it also absorbs energy. So the length of the system is actually designed to be hit, 100 Ks head on with a 2-ton vehicle, and all that energy will be absorbed by you get to the end, which is actually, a big difference when we talk about sort of wire ropes and this, because it is going to absorb a lot of the energy. And if there are, hazards nearby, you will reduce that severity because you've absorbed a lot of energy. Now, after an impact, it looks something like this. That would be very rare, because that looks like all the energy. Most impacts are going to be happening at lower speeds because someone's had a chance to brake, or it's not a full-on 100K run off road straight into it. But there's what it might look like, and I think this is from New Zealand. An image or a video of that looks something like this. We've got the small car coming in, and it starts extruding out. Now, in this video, it's an offset impact. So we can see it doesn't hit in the center, which is great because we're trying to understand that rotation. So yes, eventually there is no longer enough energy in the vehicle to keep pushing through the rail. So at some point, it gets to a stalemate of saying, I haven't got enough energy to push. So the barrier, the terminal stops. And then that leftover energy, which is far less than the impact energy, there will be some rotation. And again, from the head on. Now, the other type, the other two products, the ETSS and the max tension, use a different approach, and I haven't drawn it from the top or from the side this time. The rails still overlap, so you've still got these sort of the W-beam rails overlapping each other. However, as you impact the end, they concertina over each other. So this one shifts and slides over the top of that one, and then those two slide over the top of the third, and then all three slide over the top of the fourth. And during that, there is an anchor point that kind of absorbs that energy. So as this point gets pushed along, it's actually pulling against this anchored cable or rail. And therefore, by the time you get to the end of it, all of that absorption, all of that energy and that friction has absorbed the energy of the impact. So obviously, when we talk about the biggest mistake you could ever make of these two systems, and I might go back, the biggest mistake you could ever make is not putting the head on the end of the rail. And, there have been some scenarios where the installer was maybe rushing or they weren't aware of that, and you can see the W-beam sort of sitting outside. That means completely not going to work. So it is really important to kind of understand how they work so that we know the biggest factors of installation. In this one, biggest mistakes you could make is maybe, concertina, so overlapping the rails the wrong way, because they're no longer going to slide over each other. But also there is a locking, or sometimes there is a locking mechanism in there that provides that friction. If you didn't lock that, then, this would almost be free flowing. Yes, there'd be some energy absorption as they concertina, but, this is doing the majority of that energy absorption. So here is a video. Oh, I think hopefully there's a slower speed one. I think there will be. Videos a bit longer. But we can see there, can I pause this? So before it hits, and maybe I'll go back a second, sorry about that. You can see the anchorage. So the W beam comes through the end, down, and then it's anchored to the base. So there's going to be that continuous connection all the way through. And as you can see, in this case, there isn't the concertinaing, but it's being pulled through the head. It's absorbing that friction and it's remaining anchored at the very front of it. And by the time it gets to the end, it's absorbed the energy. That was 100 Ks. The occupant ride down values, are below threshold. And so it actually is a fairly good outcome. We can see that it remains anchored over there at the front. Let's keep going. Crash cushions, and maybe I'll stop after crash cushions for some questions. Crash cushions, similar to the terminals, you've got a matrix of tests that you need to undertake. They do perform very well, but obviously they come at a cost. Now, the great thing about the crash cushions is they're basically standalone. You could place it on the end of a pier or some sort of hazard, and the terminal itself does enough of the redirecting and impact absorption. In the other ones, you will need to attach it to a guard fence or a wire rope, and you'll need some distance to support that terminal, but these are very standalone products. Tested to 100, can be designed for larger speeds if you really wanted that extra conservativeness. Fully redirective, so if you do hit at an angle on the side, you will be redirected. Obviously, if you hit on the end, it'll absorb the energy and bring you to a stop. Here is a video of that. So this is a 100 Ks at that's head on, but the angle is next. And basically, those cartridges are crushing and absorbing that energy in a very effective way. It does mean that after a big impact like this, you'd probably have to replace almost all of the cartridges. But, we're talking highways, gore areas, near off-ramps. That is a 100 K impact at an angle as well. So they are very, very effective. Obviously, as I just mentioned, most systems work on a cartridge model where you have basically a crushable type device in the middle. And basically the barrier just sort of crushes over itself. You will need to replace each of these after a big impact. Slightly different ones, barrel versus cartridge. Some of the cartridges are different. So the first one is often slightly weaker than the back ones. And that's so that the small car, gets a bit more of a gradual deceleration initially, and then once you've decelerated enough, the big cartridges are the same size, but the stronger cartridges kind of kick in and do the majority of the energy absorption. The only different one is the smart cushion, which comes at a price, but it is very, very good for a couple of reasons. It uses a hydraulic system, so there's no cartridges, and it's probably not a great photo, sorry for that, but there aren't any black cartridges in the middle. What happens is that there's a cable underneath attached to a hydraulic sort of piston type system. When this gets impacted and starts crushing, it's attached to that cable. The cable pulls on that piston and it actually absorbs that energy very consistently over the length of the crash cushion. The big benefit of it is you've got no cartridges to replace. If you get a very neat head-on impact, you can just pull it out, you can reset the cartridge, and it's pretty much good to go again. So there have been, in a really high volume highways, in the gore sections, tough to get into and repair. We have been going with the smart cushions because of that, quickness to fix and also the whole of life cost. But it is definitely a bigger investment up front, and they all, in theory, even though there's the pros and cons, they all pass the same crash test matrix. And here's sort of a couple examples. I'll come to you, Ken, in 2 seconds. A couple of
Yep.
examples of crash cushions, as I mentioned. Good because you can chuck them on the end of a hazard that you might not have the length for a full-on barrier or another terminal. But also, if you need, can be connected to a thry beam or straight into a concrete or something. Yep, go for it. And I think there's a wider one as well. But yep.
Yeah, no, there was a question earlier around the sort of environmental sustainable characteristics of barrier systems overall. So are they using recycled materials and the like? I know also, I suppose, the crash attenuators, some of them have oil products in them and different bits and pieces. How's that all considered?
Yeah, it was something we added to our assessment criteria at ASBAP about 12 months ago. No, a bit more than that, probably 2 years ago. And first up, we just said, okay, we actually want to know about this, and the suppliers now actually have to put that in their submission. What is the debris? What is the potential risk? And also, when we're done with this product in 20 years, how do you dispose of it? What are the materials and what's the disposal process? So we have started to take that into consideration a bit more. I guess, yeah, like to date, they're all fairly similar to each other. And yes, there's a lot of steel and yes, you'll get a lot of damage. And obviously that steel can be recycled. In some cases, we kind of noted the excess debris of post caps and this and that. And we've tried to limit that and say, well, we don't want just everything going everywhere and then it being left out there. So I think, look, in general, they're fairly well, good. There is no sort of modern day products that have that sort of potential leaking in, any contamination into the soil around it. But, I guess from the plastics perspective, there could always be improvements. I'm not saying it's definitely perfect, but yeah, we have been pushing for better thought in that space. And I think it's been getting better in the last 2 years.
Okay, thanks.
All right, so that's it for crash cushions. Just wanted to highlight too that another value of crash cushions is, you just wouldn't have the length to extend the barrier all the way up in this scenario, which is a gore, obviously 2 different exits on a highway. So you can install configurations like this for those scenarios. A couple of other odd ones are the short radius curve treatments. You may have seen them. You generally use them on sort of the high risk. Sometimes there's a bridge here, or obviously a giant sort of very steep batter. If you ended the guard fence, you would leave that exposed. The idea of the system is that there are a whole bunch of timber posts or breakaway posts on the very corner. And when the vehicle impacts, they do break away and it kind of, almost like a net captures the vehicle. They are, they don't perform as well as a great system or a crash cushion. But I think we acknowledge, in this scenario where it doesn't even matter if someone ran off at 40 Ks or 60 Ks or 100 Ks, it's going to be a pretty bad scenario. So obviously these work better at lower speeds, and I think 80 to 100 is kind of pushing the limits. But on a whole, on a net safety gain in a scenario like this, they are there and they are available, and they're better, better impacting this, especially at a lower speed and being caught before going off than just going off. But again, not for major use just on all roads. It really is where that hazard is quite serious. Transitions, every transition goes through the approval process. Not all through testing. Often you're either going for the small car or the big car, depending on which risk you can justify as greatest. The idea really is that you have to gradually go from a flexible system to a less flexible, from stiff to stiffer. That's done over sort of over a distance. So in this case, we've got the classic sort of guard fence into a concrete. This would have a deflection of around 1.5 meters. This would have 0 deflection. And we have to gradually increase by adding post spacings as we move in. Austroads has actually just developed a new transition that includes some W-beam, then Thri-beam, and then into concrete, which we have just drafted up the drawings for that. And we'll be moving to that new transition next year, or at the beginning of next year. And the idea is all the suppliers are currently showing how they can connect into that transition. So there'll hopefully be one transition for basically all guard fence or Thri-beam systems into concrete, which will be very useful. The idea here is that we have this effect called pocketing. If someone impacts the guard fence and it kind of deflects into the back of the concrete, that would be considered pocketing, which is a safety issue. And that's why we have these extra posts. So as someone is coming in, it can redirect before they impact the end of the concrete. And actually that is the Austroads transition that we'll be adopting. Again, this will be the first time that we all harmonize across all the states in New Zealand on the one transition. We've all had subtle differences, but it'll be the same components, the same posts, the same everything in all the states, which is going to be really great and going to make it easier for manufacturers. And you can connect from W-beam or straight into Thri-beam into concrete, which would be very good. A couple of other products, Raptors and energy absorbing bollards. Now, is an interesting device, and I think we have a need for them, which is why we continue to publish them. They've gone through some testing, not the full scale MASH TL3 or anything like that, but they do absorb energy, and more importantly, they do stop the vehicle. And so, they're really should be used and limited to the constrained locations where we couldn't get anything else. The idea of the Raptor is it's just a whole bunch of plastic that is going to spread the load, absorb some energy before you impact the pole. Again, still not as good as a barrier which would redirect you away and sort of pass that energy down the road. This will have to bring a car from 60 to 0 in a very short space, which is still not great, but better than hitting a pole. Similar with bollards. Yes, they will bring a vehicle from whatever speed to 0 instantaneously in a very short distance. There might be some deformation, but overall, as a safety device, better impacting that and utilizing the airbags and the seat belts and the crumple zones of the vehicle at 60 Ks and less than taking the risk with the pedestrians. So again, bollards are in there, but I wouldn't be substituting these as an alternative to barriers. And in fact, you probably go through a process of designing the barrier and potentially even accepting a lower deflection, saying I can't achieve the full deflection of the guard fence or the length, but it's still going to do a better job at redirecting most impact scenarios than potentially a Raptor or a bollard. Maybe there's a video here. I actually can't remember making this, but there is a really great video actually that maybe I have the link to somewhere else, but there's a really great video online that shows a whole bunch of crash testing and goes through the products. And I think that's what this slide was. I can't remember, Ken.
I'll send that link around,
yeah, perfect.
Evan. That's the one you sent myself and Jamie a while back, isn't it?
Yeah. It takes a while. I think it's like a 15-minute video, but it's actually really, really good. Rigid barriers, different to the rest because there's a bit more design in the barrier itself. And that's why they're kind of here at the end. With concrete barriers, what we know is the shape and the impact surface and profile, that makes a difference. The reason why it's called F shape is because they tried a whole bunch of different shapes called A shape, B shape, C shape, D shape, and they recorded the occupant severity on each of them. And the F shape, which is really just the slight, the angle, the offset, the toe height, that's what makes this one stand out, is slightly better for smaller cars. It It raises the vehicle a little bit, absorbs energy that way, which is why we've gone with the F shape as our preferred profile. Some states and countries will use a vertical slope, which again is just a straight angle down. Again, the shape really just influences how severe it is to impact. Obviously, the vertical face, wall is going to be the most severe, but in theory, still stops a vehicle. So in Victoria, F shape is preferred. Beyond that, it's all about height. Obviously, the higher it is, the higher the containment level and the larger vehicle you're going to be able to stop. So 920 is that minimum for MASH TL4, and pretty much if we're installing a concrete barrier, that should be the default. 1100 high is the default for MASH TL5. So it's still F shape, but the height is what's going to make a difference. Then beyond that, it's really just about making sure that system is anchored. And there's going to be the right sort of combination of reinforcement, connections between units, anchorage, how deep is the anchorage, and obviously the terminals. And really, that is about making sure that the system remains, rigid during that crash test scenario. So shape, I did talk about that. New Jersey shape versus F shape. Yes, there is a difference. A lot of people still say Jersey barrier, which is fine. There are still some New Jersey barrier out on the network, but in theory, if someone says a Jersey barrier, they're probably just meaning F-shaped barrier, which looks very much the same, just a slight change in the shape. Height, installation, sorry. We provide a default or a standard installation technique, and that is basically embedding the barrier in asphalt. Obviously, you could anchor it however you want, whether it was a board pile or some other technique, which is fine. But to try and optimize the cost of concrete and make it a really practical, worthwhile solution, we provide a standard embedment technique, which is basically embed the barrier 75 mils, embed the barrier 75 mils in the asphalt, and have a minimum length. So do that for 48 meters minimum so that the mass of the concrete and that connectedness provides that structural strength. Obviously, if you haven't got that 48 meters, if you haven't got the 75 mils, then there are plenty of other ways to try and anchor the barrier. But this is sort of our good default for long lengths. When it comes to attaching concrete barriers to something else, being a structure or a retaining wall or even a culvert, then we're moving into the space of saying that barrier is now attached to a structure, and therefore it has to be designed to AS 5100, the bridge design standard. In that, it's kind of a similar process. It is about what's your shape, which is F shape, what's your height, which is going to mimic those heights I just talked about. However, the anchorage technique and the reinforcement and all those sorts of requirements are going to be different because it's now a structure. It's part of the structure. It has a different design life. It has a different way of repair and transferring load. So if you are attaching a barrier to a structure, or you need to, you kind of want to get onto it early because it does take it is a bit of a design process to get that done. There is a table that kind of gives some equivalencies, and the idea is that low or regular is designed for the same vehicle as TL4, medium to TL5, high. However, even though they're designed for the same vehicle impact scenario, they are very different in how they perform. The fact is that performance levels are anchored to some sort of structure and therefore have a whole lot of different requirements. So often we say there is no equivalency. You can't just chuck a wire rope barrier on a structure and say, oh yeah, that because it's equivalent. No, because that barrier is now connected to a structure, it would go through its own process and you would never end up with that scenario. In the past, when we talk about profile, we do have two options. Obviously, F-shape is a very good profile for impact scenarios. But in an attempt to bring in aesthetics and allowing people to be able to see the environment behind it, We do also have a 2 and 3 rail bridge barrier that looks something like this. Minimum heights are still there. The spacing and the heights of the rail are designed specifically. Otherwise, these are some low speed examples with some throw protection on top, a 2 rail on concrete, which it gives that aesthetics for people to be able to see through rather than just having a giant concrete wall. But you can notice the F shape down the bottom. So that is it for permanent products. And up next is temporary. But I reckon I'm happy to stop for any sort of questions on that. And temporary is fairly fast. So.
Okay, thanks for that, Evan. No specific questions. There was one that a couple that I clarified behind the scenes. One around end terminals on the other side of the road and crashing into those, which I mentioned there was a crash test for that, for the reverse direction.
So I think, on that, there are definitely some terminals that are called departure-only terminals. Now, they don't absorb energy. They can't be impacted head on, but what they do is they anchor the system. And the classic example is the trailing terminal. That anchors the system, but it shouldn't be impacted head on. Now, in the past, we used to say, as long as that terminal's far enough away from the other side of the traffic lane, then the likelihood is low. And we used to say you could install trailing terminals when it's outside the clear zone. We've got rid of that. If someone can impact the barrier head on, you need to use a crash tested terminal, unless you've got a barrier in the middle, stopping you from impacting that. In regards to those terminals, yes, you do have impacts in the reverse direction. Now, the biggest risk is going from a flexible to a more rigid. So if we're talking about going from maybe a thry beam to a crash cushion, you're going to have that pocketing, and we pay really close attention to those crash tests. However, going from, I don't know, what might it be, from concrete to a less rigid, a guard fence terminal, there's not going to be much of a reverse direction risk. But yes, you need to know what barriers can be connected, and there is an important factor there on that reverse direction.
Good. Any median mash tested terminal yet?
No. So yeah, good question. There isn't. And when we say that, obviously crash cushions are, so that could be your one mash median terminal. However, when we're talking about median, I know we're talking about the old extension, which, is really just a back-to-back great terminal. They've done the testing, they're close. There was some questions around one of the angles that they used, and they're currently in negotiations with America, because that company in America is the one that owns it, about do they want to invest just for those annoying Australians, which we're encouraging. Yes, we want it, and yes, we will have it in Victoria. So I'm trying as hard as I can to get you a median terminal, but it's not here yet.
Okay. And I suppose for the group there, the reason I wouldn't want to use a crash cushion or attenuator as that is it's damn expensive. And
that's it. Yeah, that's fair.
What are they costing? 25 grand or so, and you get a back-to-back for about 5 grand.
But that's it. Yeah. And look, very different. Like, it's not equivalent. The crash cushion still performs better at every angle. The median terminals are still assuming that most head-on impacts are only coming from one side. So yeah, look, a crash cushion is definitely expensive. I don't think it's worthwhile in your typical median scenarios. Having said that, it can be done, and they are very good products. The other thing though is if you put a crash cushion in the median, you've now got that scenario of a flexible barrier into the end of the crash cushion on the opposite side. So at this stage, we're allowing the old extensions because I still think that's got the net positive benefit. It's cost effective. We're getting the protection. We're not wasting money where we don't need to be. But I hope to have a MASH median tension terminal soon.
As questions come in, I'll just read it straight out. How do we transition from medium performance barrier to MASH TL3? 100% sure.
So medium would be sort of a bridge barrier. So it'd be a concrete barrier of a certain height, medium performance. If you were going from that to something else, well, you're going from more rigid to less rigid. So we would have a transition. You could connect your guard fence to it. And the idea is to slowly transition the height down so that they're even, and then continue your guard fence off. In that case, it's really just making sure that W-beam is anchored, because you're going from rigid to less rigid. If we swapped it and said going from guard fence to medium, then we have a big issue. Not an issue, but we have more factors. We need to gradually transition. In that case, we would be talking about guard fence through a 10-meter transition to the concrete, so that we're getting from guard fence to concrete. That concrete at the very end needs to be a certain height, so it's not the 1100 that you would need, and therefore you need to gradually transition from that up to your medium performance, which would be 1100, I think. So it's not an instantaneous thing when it's going that way, and you really need to consider that. But the other way, it's not too bad.
And when you say that, it's really the direction. It's the direction of travel, as long as you can't get to that from the other carriageway.
That's true.
So
very much. Yes. Yeah. If this was
that
on a one-direction carriageway with a medium barrier, you might be. But if it was a two-way bridge and someone can cross over, you'd need that transition on both sides, 100%. Yep.
Spot on. Good. Okay. Well, keep the questions coming in, everybody. Evan's going to switch over to some temporary systems.
Yep. So temporary is last. And I guess I was just also thinking of just halfway through this one, but I was just thinking about probably a good time to come back to Tim's question earlier on, which is about the selection. And, I guess in my mind, it's a bit of a, you start with the list and you slowly rule out the barriers that aren't suitable, wouldn't work in that scenario until you end up with a smaller list. If we had a perfectly unconstrained highway with plenty of room, plenty of space to the traffic lane, we didn't have too many heavy vehicles, TL3 was maybe what you needed. Well, you basically got every product available to choose from. But, as you start going and going, okay, we're on a curve. Okay, that rules out wire rope. Or, maybe we need to connect into a bridge a kilometre down the road. Well, we can't connect wire rope straight into the bridge. Then let's go with guard fence. Actually, we have 30% commercial vehicles. Let's go with MASH TL4. Now that's going to rule out your TL3. So there is that sort of, process of just cancelling out what you can't have. Okay, there's no room for deflection, concrete, I've got to attach it to a retaining wall, concrete, So you are kind of limiting it that way. But once you've ended up with, okay, here's what I've got, generally it's kind of, okay, which is the most forgiving of the ones that I've got left? Can I reduce that impact severity? Is it going to be a good whole of life decision? So it's generally the process, but it is kind of takes a bit of practice and understanding of the systems to kind of know what to look out for. I've got a culvert, I need to get over that culvert. Okay, is that going to limit it? Or I've got curves. So even though you start somewhere, you quickly get somewhere else sometimes.
Yeah, I think that's well summed up. And the real world is messy out there, and you're always dealing with challenges, constraints, and community wants one thing and these, and you're trying to balance all of this out with many different things. But we're trying to give everybody here bits of information, and you'll start to be able to piece that puzzle together yourselves over time as you gain more information.
Yep, definitely. And look, just on that, I mean, in the designs that I've done quite a while ago, it is always worth taking that step back, and Jamie will probably cover it after you've done it. You can get very into the detail of going, okay, this is the offset I need and the deflection, and you step back and you look and you go, I've got wire rope here, guard fence there, then I've got a crash cushion, then I've got guard fence, and I've got concrete. Whoa, is this actually a good outcome in the end? And then, you take that approach and go, okay, well, let's take, some risks, and maybe I can't achieve deflection there, but, the choice is all guard fence or all wire rope. And, from a higher level, you can sort of justify some of those constrained locations, because ultimately you're providing a much more consistent, experience for the road user. And in theory, achieving 1.5 meters deflection versus 1.45 meters deflection isn't the difference between pass and fail. It's the difference between slightly fewer impact scenarios not being catered for. Maybe no longer the 85th percentile, but the 84th percentile. Now, it's worth acknowledging, you don't ignore it, but it doesn't all of a sudden mean it's a failure.
Yeah.
Versus leaving a concrete end block exposed, then I'd be like, that's high risk. Yeah.
Yeah. And I think, I really like to see design reports that just point out those considerations, so it's clear, exactly as you said.
Yeah, definitely.
All right, we've got just under 20 minutes to go for you.
No worries. I'll take about probably 15. It's all right, and I'll give you back 5. No worries.
Yeah, no worries.
Alrighty, so temporary barrier systems. Now, often the same designer is not using both systems, because either you're sort of a road designer designing permanent systems, or you're in the traffic management plan space and using temporary barrier systems. But the fundamentals, everything I've talked about, is pretty much exactly the same. We crash test them the same way. We've got the TCUs for them, lengths and pinning and heights. Well, not heights because it's the product's type. And then really in the site, you're really just going, okay, well, what product do I use? How do I anchor it? What are the lengths, etc. So it's really just the specific types that I want to cover here. Generally there is sort of an acceptance that they're there to protect workers. During impacts with wire rope and guard fence, you get a lot of debris. You're also less likely to be able to withstand secondary impacts. In the temporary barrier space, we take that a bit more seriously, because there's likely to be workers there. Are we, willing to accept a level of debris? How much does that barrier deform? Could it take a secondary impact? So, they're all tested the same way, but it's kind of what do we favor? And we, if one product or a couple of products have shown us really good performance, that kind of almost sets that unwritten bar going forward. The next product that comes along almost really needs to meet that or exceed it, rather than going back, to the bare minimum. So again, offsets, widths, deflections, and your work areas are all very similar. The different types are really summarized as these 4. Concrete, so purely concrete, often freestanding. Steel, purely steel. You then have some composite products where you've got a steel shell, but weighted down or, weighted by a bunch of concrete ballasts. And then we've got our classic water-filled plastic barriers. All have pros and cons. Our concrete ones, generally most are F-shape. The idea is that they have enough weight. So they're not pinned to the surface, but they have enough weight when connected and when used with enough units. We don't have to anchor anything to the ground surface, which is good. When we are talking about really short lengths, they're still pretty good because, they've got that weight. Obviously less barrier units means that the barrier might slide more than we would expect or want. But, if we're in a constrained location, at least these have the weight. They are, limiting it as much as possible. The different product types are really just the different connections, JJ, T-lock, and DB80. The next, steel. So this is the purely steel, no concrete. Again, all the shapes are slightly different, but ultimately they're just a steel unit connected to each other, and in this case, pinned to the surface. So, you can carry much more to site on a truck because they're lightweight and they're durable, but they haven't got the weight, which means you do need to anchor them to the surface. Now, You can anchor them every 60 meters, which is kind of the minimum. That'll give you a certain amount of deflection, or you can anchor them more regularly to reduce that deflection. The one thing to note, I guess, with these products is, obviously the taller you make it, the better containment, but obviously more steel. So the suppliers have this balance of how cheap can we make it, but also have the highest containment. When a vehicle impacts these systems, they move. And so the more they move, the more stable that vehicle is. So a lot of these systems are TL4 in one configuration and then TL3 in a separate. And basically, if you pin them less frequently, you give that barrier more room to move, they will achieve MASH TL4, but you need room, obviously. If you want to pin it regularly and basically make that product a rigid barrier, it will only achieve TL3. Now, there are some middle grounds, the low deflection systems where do achieve MASH TL4 with a much lower deflection, but just want to highlight that, the product itself, the unit might be MASH TL4, but it's going to stay the pin spacing in the TCU, and that is critical in what containment level you are actually achieving. Composite, basically best of both worlds. So the idea is that, if a traffic management company wants to purchase a product, they could have one that can be made as a composite or a steel only. You can pin these if you want, but also they have the weight. So they could act as a freestanding system. The weight inside will almost make it act like a concrete barrier, but it's got the extra durability from the steel shell. Some more unique ones, the mobile barrier trailer. Again, I wouldn't expect people to be using these everywhere. We're really talking your transurban and your managed motorway owners. The idea of being able to get out on site quickly to fix something or do maintenance. The trailer or the truck itself is actually fully crash tested. You can have one unit or you can have three. There's a whole lot of complications on how you get it to site and around the network. But, it is worth knowing that stuff like this does exist. This allows them to keep the speeds high while also protecting their road users, or their maintenance teams. And, when you're evaluated on efficiency for motorways, that is often a target that they're trying to achieve. Plastic water fields, again, slightly different shapes, but they all pretty much work exactly the same. You have a plastic shell with some water in it. The terminals might not, are typically the only units not filled with water. The rest are definitely all filled with water. As a mass, the water adds weight and therefore they're freestanding. Obviously, the shorter the system is, the less weight it's got. Therefore, it's not going to, it's going to deflect more. If you don't fill it with water, you have nearly no weight. It's just going to get out of the way. It's going to break and the vehicle's going to go into the work site. So still very good for lower speeds, that it's really quick and versatile, easy to move. But obviously, weight is still the fundamental concept there. In summary, maybe you can go through that at your own time if it's in the slides, but plastic, TL1, TL2, 50, 70 Ks. In your concrete and steel, concrete used to be around the 80, but they've just done a whole lot of work to get it back up to 100. And steel is 100 plus that MASH TL4. So if you need high containment, you're in the steel space. If you're fine with TL3 and you need freestanding, you're kind of in the mixture here. And if you're lower speed, you generally are going with a plastic, though all of these are fine in a lower speed environment.
As for which is the quickest to install? Is the question.
To be honest, I actually don't know. If you chucked your plastic barrier out there and just didn't fill it with water, then that would be pretty quick. Which I think a lot of contractors think that is how it works. So I think one factor is how much you can take on one truck. So you've got the fact that you could get a whole lot of units of steel and plastic to site really quickly, but then there's that deployment of, you've got to fill it with water or you've got to anchor it. On the other hand, concrete, you can only sort of get 6 units there. It's going to take a bit of work to get them off the truck, but the second you put them down and interlock them, they're good to go. There's nothing else to do. So it's probably hard to give which is the fastest, but it's probably the pros and cons of each of them.
Yep, thank you.
Terminals, there's basically 2 types. I didn't really go into it before, but it's the gating and non-gating, and I think Jamie might talk about it a bit later. But basically, again, the terminals are just there to protect the end of the barrier. They don't have to be doing the redirecting. Therefore, most of the temporary terminals are in the gating section. They just provide some sort of crushable component to the front of the barrier. There is a run out area, which is kind of a value based on some crash testing some time ago. There's actually a new TCU out. I, through ASBAP, did a whole lot of work in looking through a lot of the slower speed crash tests. And there's a technical note that's come out from ASBAP, which will go into the next Ostroads guide, that talks about run out areas in slower speeds. And basically it gets less because the terminal is absorbing more energy and the vehicle travels, it doesn't travel as far. In that space, I'm going to skip over this, but so this is a very old test. None of the terminals perform like that anymore. However, that was a pass at some point in time to the old NCHRP protocol. The idea was that the barrier, didn't spear the vehicle or anything. The occupant risk values were still fine, but obviously it's the ugliest thing to have a look at, and we wouldn't want that. So really it is kind of a reminder that some of those older terminals did have that performance, but on all the new impacts, 100, 20 and 70 and 50, they all look very, very good. Plastic terminals look something like this. Sometimes the first couple of units aren't filled with water. Sometimes they are, going to depend on the specific product, but also they're all connected to the other barrier, whether that is the plastic or whether it's concrete. These can be used on plastic, on concrete, on steel, on composite. So there's basically a plastic terminal for every barrier now. In the redirective space, we've got crash cushions, which are pretty much exactly the same as I showed before. It's the same system, the same cartridges and everything. It's really just anchored in a more temporary way. So steel plate with some pins, which means you don't have to pour a certain concrete pad. The biggest element here is the end. So we talked about the reverse impacts, and right here we haven't got reversing impacts, so it's not much of an issue. We can just place the crash cushion on the end of the concrete. If that median barrier wasn't there and we could have someone coming in from the opposite direction, that transition is really, really important. And that's what's been sort of taking the time with crash cushions being approved on all the different products. By now, I think there's pretty much multiple crash cushions that are compatible with multiple barriers, whether it's concrete or steel or whatever. So it's worth checking the TCU to make sure that combination does work. And, basically that is about that transition and making sure we don't get any spearing. So like in short, like for temporary works, very, very similar to everything I've talked about. For permanent, the main thing is really going to be about make sure your units are connected together or filled with water, because that adds the weight. The weight of the systems are the most important thing. And if you haven't got that weight, the anchorage to the system is going to be the most important as well. When we talk about short lengths, these factors come into it, because, the reality is you're not going to have these lengths everywhere, but understanding, okay, if it's pinned, then maybe I can get away with a shorter length because it's still anchored. Or if I've got, a freestanding system, which one is going to give me the most mass? So using this information allows us to go through that process of choosing the best barrier. Even obviously a compliant barrier is always the ideal, but often a non-compliant or a barrier that we've gone through a process is still going to be better than nothing. And giving you these pros and cons and how they work, is part of that. Being able to justify, all right, I chose a concrete one. Maybe there were services underneath. I wanted that extra mass. The terminal, I could use a 1-unit plastic or a 2-unit plastic terminal on it. So it's that sort of process. That is pretty much it for me. I know there's a lot of information, and I know the exercise will definitely help, but hopefully from that you sort of go, what are we looking for from the crash testing? Limitations of it. It's not pick the worst, it's pick a reasonable range of crash tests and make sure they pass the acceptance process to make sure we cover off products and variants. And then there's obviously a whole range of different products and their pros and cons in both permanent and temporary. I doubt there will be lots of new products in the near future. There'll be lots of new variants, which is great because it means that it works in a whole lot of different scenarios and we don't have to take as much risk as the designer when we know that product works with a 1 meter post spacing, or they've tested it at 70 Ks rather than 100 and I know they're working with. So as the variants get submitted, obviously that range of knowledge increases, which will be super, super useful.
Great. Thank you, Evan. We'll just see if anybody does have any final questions for you. And I encourage anybody to either pop it into the chat or even pop your hand up if you want to just talk directly to Evan. We do have a few minutes here, which I'll then be taking you through the assignment you've got to do, which is very, very relevant to all the stuff Evan's been covering. But as we do that, a couple of things. So on Friday, we have another session and we have time allocated in that session for some interactive discussion and the like with participants. So if anybody has a particular site or is doing a barrier design or has seen something and they'd like it discussed, please send it over and we will make sure we include that, or you can bring it along on the day and we can work through it then and there. So there's a bit of time allocated for that. Yeah, we're covering off a few different topics and Evan sort of touched on a few of them and a few words you might have been a little bit confused about or not quite sure about, like working with and these sorts of things. We'll elaborate into quite a bit of detail as we head into it on Friday. So thank you, Evan. Appreciate your time. Wonderful information again, and a huge amount of information to the participants in a short time. So thank you.
No worries.
Right, I'm going to run through the assignment and I'm just going to jump into Moodle here. So I'm just checking I've still got everybody here. I had a little error pop up there that Zoom quit. Can somebody just type in that they can?
I'm back and I had that error. So hopefully I think everyone else is.
Okay, yep, good. Yes, and people are saying they're still there. Yep, everybody's still there. Sorry, I thought I'd lost you all, but can't get rid of me that easily. Right. So in Moodle, you'll see here, you've got, I will be uploading the video of the session in here, but I put that video that Evan mentioned here in the resources. So you can have a look at that. It's about 15 minutes, as Evan says, but pretty cool stuff. It's probably a good one to share with others as well, if they want just some very basic stuff. There's some resources and the like in those folders as well. So have an explore around that. Down here, you'll see we've got the quiz for Evan's session there. So there were a few Wallies in Evan's session. there was some Wally in Jamie's and mine. So the Jamie and my presentations, that's a Wally question, and you would have, a lot of you have already done that. There's a second one in here, so it's a separate module. There's some Wally questions. There's less than 5. I'll give you a clue on that for Evan's session. Now, you've got some time to do these quizzes. So if you missed the first one, you had some technical troubles, don't worry. You can do that at any point along the journey. We just wanted you to have a go at it. I apologize for those who didn't quite get much of a break or any break because they were trying to do the quiz. For Friday's session, we won't get you to do the quiz in between in order to give you an actual proper break. So I apologize for that. But you're into the Know Your Product. And this is your little assignment for this course. And so you click onto that and you download there. It's got some instructions. You download the Word document and you download the PDF, which is your product. So you'll have a look here at the PDF and you'll go, okay, here we go. So you'll find your name and you'll match it up to a proprietary product. I think they're all proprietary. I don't think we put any public domain systems in this one. So you will find your particular product and then you'll go back and you'll have a look at the Word document, and that'll help you then to fill out exactly what you've got to do. So you'll see here, we've tried to make it very easy for you. Anything in yellow is going to be what you're going to have to fill out. So you put your name, you put your jurisdiction. Now, you're all Victorians except for Paul, so everybody will put Victoria. Paul, you can put Queensland, obviously. And then you will write in that product that you've been allocated. Then we want you to write the status of that product in your jurisdiction. Is it conditionally accepted, discontinued, legacy, not accepted, accepted? And then what test level is your system? Is it MASH TL3, TL2? Is it NCHRP 350? Tell us the level that system is. And then this one is going to require you to dig in a little bit better, maybe into the sheets attached, because we want at least 1 up to 3 advantages of that system compared to other like systems or things that would do a similar job, and 1 to 3 disadvantages. So yes, you'll find it, you'll find the product, you'll find on the state road authority what it is, accepted or not, or the like. You'll find what test level it is, and then you'll find some advantages or disadvantages. Ritu, I think you've got your hand up there. I've unmuted you.
Yeah, I was just going to ask, do we get marked accordingly if I give 1 example as opposed to 3?
No, good question, great question. No, if you put 1 advantage and 1 disadvantage, and they are both good ones, you'll get the full marks there. You can't possibly get more marks by adding more. Good question. Now, Hamantha, you have your hand up. You can unmute yourself, hopefully.
Where do I find the information from?
So you're going to have a look at Evan's presentation there. He went through, he showed you on the VicRoads website.
Oh, yeah, okay, yes.
You go to the road design node 0604.
Yeah.
That's going to be a very good starting spot. You'll find that product and then just go from there, because there'll be links that will take you to different further information. What do we got? Paul. You should be able to unmute yourself now, Paul, as well. Okay. Paul may have dropped off. Any other questions? So where do you find the Word document? Okay, so that is in Moodle. I'll show that again for those who missed it. But in Moodle, which is here, and just go back one there. You've got all of your things. Know your barrier product is the assignment. Click on that, and then you go down, and there's the Word document with the product list. Now, if anybody has any trouble there, please get in contact with me, give me a call, shoot me an email, and I'm more than happy to help you out there. Now, I don't know, Paul, if you had your hand up and we've given you the ability to unmute if you wanted to talk.
Oh no, sorry, Ken. That was a mistake. I'm not sure.
Right, you were just waving. Was it
just
a
waving
hand,
something like that?
Not a hand up. Oh, good.
Yeah.
Okay. Any more questions? Right. The other thing, I'll just remind you there. For Friday, there is time allocated for live looking at different issues you've got. So please bring some live examples. Bring some challenges that you may have, designs that you've got, particular sites you find challenging, and we will live work through those. We can street view jump into them, or if you've got photos, send them through. And Jamie and myself will make some comments, and others in the group might be able to add to them. Yeah, so have a go at that quiz and that assignment. It'd be good if you were able to complete those before Friday's session. If the crazy world takes the better of you and you don't have time to do that, we understand completely. But you'll be able to sort of wrap everything up shortly after that. And the reality is we can't give you the certificate until you successfully complete that assignment and the quizzes and get that benchmark. Any final questions? Now, if you log in a little bit early on Friday, a couple of minutes, 3 minutes early or so, 2 or 3 minutes early, you'll be a chance to win a prize. I'll do a little bit of trivia just to get us back in the spirit of it. But thank you very much, everybody. Thanks for your participation. There was a lot of information thrown at you. We're trying to give you lots and lots of information for you to be able to then take and run with, and you can go back to the video, which we'll upload, and you can rewatch different bits and pieces. We've given you lots of resources. Okay, thanks again, Evan, and thanks everybody. We will see you on Friday.